You're on.
I think Jamie's up first.
You going first?
Yeah, I think I'm going first.
Oh, sorry. Pledge allegiance first.
Okay.
Pledge allegiance
To the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
I'm going to put this up here just so you guys can take a look at it a little bit. I have a few things to hand out. Okay, I can do that. First, I do. I didn't. What I'm handing out is a couple of maps that we'll be talking about. That'll be the first one. Which one was? I'm going to keep one. Thank you. Yeah. You can actually have that one too. Just put this one underneath it. A moment. So this, if you wouldn't mind, underneath that one. Thanks. That's what it should be. So thank you, Joe, for inviting me to today, and I think the main goal that I have, that I think is the goal that you have, is for me to kind of give you an update as to where we are on the artificial recharge investigation. We're not completed with it, but we're getting closer, and really to talk about to address some of the questions that the board had on the process, what the advantages are. So I thought maybe I'd start off just kind of summarizing why did we get involved in the artificial recharge to begin with? What are the potential benefits for for the district, and where are we headed next, or what are the next steps? And I think the goal has been, as you know, in the last 25 years, we've been actively looking for new sources of water. We started off with putting in 7 and 8. We put in Mitchell Woods. We started looking at the Wright Farm. We've looked up and down the Merrimack River Valley, up in the Babusick Brook region, and then so we've been actively seeking new sources. Artificial recharge hasn't really come onto the scene until the last 3 or 4 or 5 years. And what that was based on, the first one, which we did with Underwood in New England and in New Hampshire, was for the University of New Hampshire and for the town of Durham, where they were taking water from the surface water sources, and they were concerned that if there was a drought, that they might not have sufficient water. And so in the Spruce Hole Aquifer, we determined that that was a good candidate for adding artificial recharge from the Lamprey River. We did build it, we got it permitted, and lo and behold, in the drought of 2016, when we were in desperate shape, there was no water coming in the intake structure in the oyster, and limited water available in Lamprey. So all of the water that they were actually using at one point was the wells that they had. One was from the Spruce Hole and one was from another well that was there. It was the first one that was permitted in the state of New Hampshire, and it won the state's sustainability award, the Water Sustainability Award for 2017. It's not the solution for every town, but in the context of other communities like Dover, Newmarket, and then talking to Merrimack, we said, you know, well, how do we get additional capacity without spending a lot of money? And the thought was maybe wells 4 and 5, which at that point were permitted for 870 gallons a minute, but ironically they were only capable of pumping about 420 gallons a minute. Is there a way that we could enhance the capacity of those wells? And this is, you know, as part of just the overall yield capacity issue. So, given that we had a problem with PFOA and PFOS, and that those 2 wells got shut down, then it became an idea as to whether or not, okay, Saint-Gobain came in, took on the responsibility of being the responsible party. A plan was put together. Saint-Gobain settled on designing a plant for treatment that would be at the basis of the maximum capacity of those 2 wells, which was 870 gallons a minute. Not, you know, not being necessarily required to go to that point, but it gave us or gave you the option that if you were able to treat that, use that much water, you could treat it with the new capacity. So that was one item. Second item is, how do we deal with, you know, some other issues with, you've got wells that have high chloride and sodium, like well 3. You have high iron and manganese, like well 3. Is there a possibility that we could develop a source or additional capacity that would maybe eliminate the need for another well for treatment? Forget about PFOA and PFOS right now, but just talk about sodium, chloride, iron, and manganese. So the thinking was, okay, we have a potential source of sustainable water, which is the hardest part in these artificial recharge projects. The Merrimack River is the most sustainable source we have in the state. And it's about 1,200 feet away, so it's very close proximity. We have an aquifer that has an ability, we believe, to take water in. Is there a way for us to add water to the system that we can later recover? And so, is there a way that we would improve, knowing we have high sodium and chloride levels in 4 and 5? Is there a way to dilute and improve the sodium and chloride levels? And really, at the end of the day, you know, Keith and I talked about in the past, and Mike, is there a way that we can lengthen the lifespan of the carbon filters? And if you reduce the amount of PFOA, PFOS that goes through those carbon filters, are going to be they're going to last longer. We have a 5-year, is it 5-year agreement with Saint-Gobain to fund the operation and maintenance. So whatever we can accomplish in that time period to lengthen the life of the filter of the carbon, the better off, you know, the Merrimack Village District will be. All right, so those are some of the justifications for that, and I think that, you know, we're going to talk a little bit about Durham, Dover, how they compare a little bit to Merrimack, and is there a favorability or not. One of the tasks we were asked to take a look at is to say, all right, this figure 1 that you see in front of you, what are the possibilities for pipelines? You know, where would we be able to run a pipeline to the region? And so you'll see, I'm very colorblind, so I won't be able to tell you the colors. But if you look in the legend down on the left-hand corner, you're going to see that there's a variety of different pathways ranging from 2,100 feet from the Babusick number 1 to, you know, 4,300 feet to the Sahegan. Now, some of these aren't reasonable in any way, shape, or form, but I think if you look at the Merrimack 1 site, and if you go to your figure 2, you'll see our figure 3, you'll see that's also put on that line. And it's offset a little bit so you can see what it was going to go along, and that is, you know, this pathway that exists up along to the wells. That line is only, that's 1,250 or 1,590 feet only because it follows existing roadways. If you were to do a straight line shot, and I'll just point this out real quick. If you were to do a straight line shot, go to the second figure here. this would be the pipeline. If you were to do, it was typically following that line up to the wells. We offset it so you could see the pathway, but if you were to do a straight line shot, it would be more like 1,000 feet. You know, saying, Joe, you got that?
Yep.
Yeah.
Yep.
This is this,
Yep.
like here. We just offset it so you could see the road that it was paralleling, but if you could come straight across, and that would be more like a 1,200-foot run. In talking, to the state about using the Babusick River, obviously there's less enthusiasm for that because of its restrictions of flow, because of the amount of contamination there's concern about contamination in that river. And so clearly the best and long sustainable supply is going to be Merrimack River, and that would be where we would go. Now, Longa owns the parcel of land we'd have to cross over. They're the ones that we've been pretty successful talking to and working with down in the southern part of the, south of where the well site is now. And that would be the only parcel that I believe we would have to cross to get onto the MVD land. So you have minimal, issues associated with potential landowners. What we've looked at is to take a peek at the quality of the water from the Merrimack. And I don't have that here, but I'll just let you know that the quality of the Merrimack, the PFOS was in the 3 to 5 range, very low comparatively. I think a couple of them were 1 or 2, in terms of parts per trillion. What's curious to me and what's very helpful is that we have to determine if the soils are capable of treating surface water. So we're not taking surface water and contaminating groundwater. So things like total organic carbon, those things that are floating, the leaf matter and then the organic debris that's in the river, how much is in the Merrimack compared to other rivers. So the recharge system that we're working on right now for the city of Dover, we take water from the Bellamy River. And I wanted to give you a sense that we use UV 254 as kind of a proxy for determining organic carbon. The Merrimack River has 1/3 the organic carbon in it than the Bellamy River. So that's very favorable from the standpoint of treatability. The color, just so you know on color scale, the color of the Bellamy River was over 100, and the color of the Merrimack River was around 20 to 25. So it's about 1/4 of the color. So those are two key parameters that we want to be, looking at. And we're seeing that the Bellamy, the Pudding Hill Aquifer, is capable of treating the color at 100 and the color at, the organic carbon at 0.35, 0.36. So, it does appear right now that the deposits that we have available on this site are really going to be quite capable of dealing with the treatment. We're also finding that the bacteria is usually treated within 10 feet of the artificial recharge basins. So it's kind of like how the septic system works anyways. If you put a boring in the center of your septic system, you find thousands of colonies of bacteria, and if you go to the outside of the perimeter of the septic tank, you got 10, and if you go 10 or 20 feet, you got 0. So that's been our finding all along. So where we're at now is that we believe that we have a pathway that could potentially work. We looked at the cost, and I don't want to. We're not charged under this work scope to come up with a cost, but you asked the question, and so I kind of try to dig into that a little bit more on a very preliminary basis. If you used $100 per foot for, say, pipeline, 8-inch pipeline, and sand and gravel to get it in, you're looking at maybe $120,000 for the pipeline. If you're looking for, going underneath the railroad track and jacking through that, we've been using $200 a foot about, Mike, over at in Peterborough for some of the jacking we're doing underneath the river there. So let's say you got $20,000 in going underneath the railroad track. And then you've got about $800,000 is what was previously spent in Durham for the artificial system that that UEI had designed and installed, and then but that doesn't include things like the intake on the Merrimack River. And we've got a pilot test to do, and I'll talk about that a little bit more. So you might, my guess is at this point you could be in it for, $2 million, maybe more, maybe less, but that's kind of a rough, I think a very, very rough preliminary base estimate. How does that compare to, say, let's assume, and maybe it's 3 million. I'm just gonna, if we say 2 to 3 million, that's probably gonna be within reason. But what if we were able to use this water, increase the capacity by 600,000 gallons a day, and you were able to take well 3 offline, or use well 3 only as an emergency backup? You would remove the need for an iron and manganese treatment plant at $4.5 million. You would reduce the problem you're having with sodium and chloride, because we know we have high levels of sodium and chloride on Route 3 because of the highway, all the activities that are down there. You would still retain it potentially as a backup water source, but you wouldn't. But one of the things about well 3 is that's your highest PFOA PFOS site as well. So you would potentially get rid of your highest PFOA PFOS site, get rid of your highest sodium chloride site, get rid of your highest iron and manganese site, and match it with everything that's on, on the property you already own, on infrastructure you already control. So those are kind of things, those are just the thoughts. I'm not saying that this is a definitive reason to do it, but it's certainly plenty of things to think about in terms of why there's justification for considering it. Right now, we're looking at artificial recharge basins, and I just wanted to show you what they kind of look like. This is one being built here. Quite frankly, this is the structure. Let's see if I can see that chip. But this is the modeling that we would be doing under the next step phases. But this is the kind of how we constructed them. They're very reasonably small. This is the bottom of the artificial recharge. It's essentially this water is coming up through.
That's being pumped up.
Exactly. Yeah, it's coming in from the river, coming up through this grate, hitting the gravel, and filling this pond, right? And that pond then is kind of dropping down. And this is just essentially the station. That's it. It's very small, not a lot to it.
That's where the pumps are in that station in there?
Mm-hmm. Yeah, well, Keith can, or Mike can probably talk a little bit to that end.
There's no pumps in
No
it.
pump in this, because the pump's over at the other site.
That building was a combination of the control valves that control the water that comes from the Lamp River pump station and then goes to 2 recharge basins, or there's water coming from the well which is adjacent to that structure. So we could either be pumping from the well into the system. We wanted to make sure we weren't pumping from the well into the recharge basins. So there's automatic valving to make sure we weren't doing that. And that's where all the the SCADA system stuff is and all the controls. But so that's not a pump station. I would call it more of a a control
station.
Yeah.
If you look at figure 2 real quick on what I gave you, the second figure, you'll see there's a series of test pit locations that we had dug. Those are the checkered boxes that are present. Those are areas we did a fair amount of percolation tests to determine the infiltration capacity of the soils. We've installed a couple of monitoring wells as well, AR1, AR2, and AR3. And then if you look at figure 3, essentially what we're looking at right now, and if you know the site, you'll know that where our AR basins 1 and 2, or the 2 are not labeled actually, but these 2 that are side by side are up on top of a knoll, you know what we're talking about, which we're thinking would be about 100 feet by 50 feet in size, dimension. And then the third one potentially down in that lower area, and that might be a little bigger as it becomes, depending on how that would end up. Those are the maximum. We might only do 2 at this point, but we would determine that during the pilot test. But I wanted to give you a sense of kind of what the size was. We want to make sure that we don't have breakout of water, out of the slope, and that's kind of a key component. But again, this is just this is a very preliminary estimate, and I just wanted to give you the sense that right now, what we've done and what we're gonna ultimately, we'll be submitting a report with recommendations. But we're at a point where we believe the water quality of the Merrimack is really good. We believe the soils are capable of treating the water, but we'd have to demonstrate that through a pilot test. We have identified where we think the best places are for the artificial basins. And we think that there's enough justification for you as a board to consider this pretty seriously in light of what you have decisions on other sources of water that you're gonna have to be thinking about. The one thing that we haven't really talked about too much is, when I look at the PFOA, PFOS concentrations, if I look at well MVD2, that's your lowest PFOA, PFOS, and, the combined PFOA out of the most recent analysis that you gave us this week was about 16.6 for well number 2. Well number 3 was at 27, and well 3 has been as high as 51. 51 back in April of 2016. That one has kind of fluctuated the most, well 3. When you go to wells 7, you're looking at 29.6 right now is your, let me see if I got that right. Yeah, excuse me.
I thought 7 and 8 were a little higher than 3.
Yeah, I'm sorry, they are. They're just slightly higher. But
They're all
the
close.
maximum for 3 was higher than 7 and 8. Yeah. So you had 29.6 is what you had today, but you've had at 7 is high. The highest one was 42. And then at the MVD 8, 24.3, the highest there was 36.7. I've got these long tables that have been accumulated over the years. And then the combined right now is 28. So with well 3 being a single entity and being lower capacity on an annual basis than 7 and 8 are, I think it's within the realm of reason that if we were able to double the capacity in wells 4 and 5 with the treatment plant already built, going to be built, that you could potentially consider eliminating that in your system.
What is the capacity of well 3?
Well,
800.
Yeah, maximum pumping capacity, but you don't pump that 800 all year round.
No.
It's quite a bit.
Yeah. It's one of the last ones we will fire up as we start, the pumpage starts, the demand starts increasing in the system. It's one of the last ones we start firing up.
To minimize it, just basically because of the quality is not, as good as the others.
So one of the things too, I want to just, I thought I had well 3 here for sodium chloride. Oh, I know, I have it here. Oh, before I do that, let me just look. I had pulled the sodium and chloride out for wells 4 and 5. In wells 4 and 5, the sodium and chloride back in 2003 ranged, was around, the sodium was around 45, 40, 35, and then MVD5 was around, it ranged anywhere between 60 and 40. So the chlorides were in well 4 were around 100, and well 5 were around 110. So they're pretty, pretty high. One of the things we want to do if we go to this route is there's a concern on my part, and has been for some time. If you go to figure 3, you'll see there's a stormwater retention pond. That pond is just generating a tremendous amount of sodium and chloride from the runoff from all the subdivisions there that goes into the ground. that's gonna have to be lined, and I think we would wanna do, whatever we do out there, at some point, we're gonna wanna get that storm retention pond lined, because it's an,
My understanding it is clay lined.
well, we believe that it's not, it's breached or it's, you know,
Okay.
because to have that level of sodium in, we found in one of the wells we put in here that the sodium actually in the groundwater was 500 in one of those
Oh, wow.
wells.
So is this,
I mean,
is
chloride, excuse me, not sodium.
this region not in a low salt or a no salt area?
It is, but
It's still not enough to,
Just to the north, right? That Parker Village, there's no salt.
Parker Village is no salt, the Commons can use salt, but that retention pond, if I'm not mistaken,
yeah, what
gets
is it?
everything from the shopping center off of Route 3, it all runs down to that point.
But that thing is property of the town, or,
Yeah.
right. So as far as lining it, that would be a town responsibility, not an MBD responsibility. I would assume.
I would say so. We,
You just did,
yeah,
you did
well,
that one.
they didn't redo it, I remember they, there is some growth in there, so I know at one point, probably 2009, I'm thinking, that they went in and cleaned up the trees that were growing. I believe, I wanna say we did a test pit at that point too, to verify the clay lining,
Right.
and that was all there, so.
Yeah, we did a test pit there, and I think it was just a hand dug. We didn't get in with a machine. I think it was just a hand dug, just to see, because it was indicated that there was a clay liner on it, but we didn't know, and we were concerned about it. And so we dug down and we found out, I wouldn't call it clay. I think we determined it was low permeability material.
Yeah.
Okay.
That would have, and we got a either permeability rating or grain size, and
Yeah.
I know we did something that showed, okay, this is pretty low permeability, so that's good. But there were things growing in it that had potentially created holes in that. So that could be where Jamie is seeing the higher sodium chloride.
About how thick were you seeing it, like 6 inches or a
It
foot
wasn't
thick?
that thick, it
No.
was, yeah, you know, on the oil, I think it varied, I think, you know,
Yeah.
I'm gonna say 3 to 6 inches. But I have something on that in my files, I haven't thought about it in years, but.
And was that like right at the surface, or was there a layer of topsoil above that?
There was a layer of some other stuff on top,
Yeah.
and then pretty quickly below that.
Yeah.
That was, I've got records on that somewhere.
So like roots or something could be finding
Could be
their way
going through that, and
Yeah.
therefore creating a channel
Right.
for stuff to get through.
What I do know is it's leaking. Because the chlorides at 500 are way too high in the you know. I did find the well 3 sodium chloride, and unfortunately I only pulled out to 2012, but even in 2012, without the additional, we were at sodium levels of 150, you know, in well 3, and sodium and chloride levels over 300.
Yeah, I got data here, well 3, you know, 2017 in the high mid 400s, 350 and 17.
So what I wanted to mention to you is carbon does nothing for sodium chloride, you know.
Right.
And it has to be something that, you know, you'd have to go to an RO or something of that nature. And if we're able to use the low sodium, low chloride water from Merrimack to dilute the sodium and chloride at 4 and 5, and also dilute the PFOA. PFOS would kind of a home, you know, be a home run to take the high sodium chloride well off and the high iron and manganese
Yeah.
well off. I'm just throwing it out there for your consideration. I'm not saying that's the answer, but that is something, in my view, that is something that should be thought through. And I talked to Keith a little bit about it. We haven't gone into any detail about that kind of scheme. So that's kind of the summary. I don't want to beat this up any further, except to say to you that there is, you know, I think we would have support in the permitting of it, because we're looking at trying to save energy. I mean, one of the big issues is energy saving. When you push things through a filter, you try to maximize what you're going to get out of it, and you know, I think if you will gain something on that overall. The intake structure on the Merrimack is an unknown for me. I mean, I really don't know. It's something I'm gonna lean, in the original next step was, and one of the reasons part of the funding pursuit was to get a detailed engineering assessment of the cost, more than my back of the napkin kind of approach. But, I think at some point, because of my lack of familiarity of intake structures, I think this area, when Jeff went down and did his review, thought this was a pretty good area for putting an intake. But that'd be something that you'd have to obviously think through. But I also think that we can get a withdrawal from the Merrimack. I mean, I don't think we're gonna face the kind of rigorous heat that we would have gotten from the Babusick. I know we would have gotten, or the Sehegan, because they're both protected. They're both protected to a certain extent.
Merrimack protected too,
Sufficiently, yeah, they are, but sufficient. The flow in the Merrimack is so substantial that our withdrawal would be nothing. It would be pittance.
Can you explain a little, like, the timing of the season that the pumping would happen? Is this something that would happen over the winter, spring, or would it be going through the whole
That's a good question.
summer?
So in the Bellamy, because we've got a lot of we've got the city of Portsmouth using water, and we've got low flow conditions. We're restricted, and we're actually just met at Fish and Game. Keith and I did last week to determine what flows are we going to be able to pull from the Bellamy, and we're looking at Q80 kind of flows in terms of what we could use. But the Merrimack, because I think this would be the first of its kind, I'm hopeful that there would be no restrictions. Now there may be, and that's something we'll have to look at. But I don't think that that we would have a significant restriction. We're not dealing with a small entity where we got biohabitats that are going to be affected. I mean, a hundredth of an inch of water level in that river is not going to change the biohabitats, or a thousandth of an inch, whatever that might be. And we're kind of struggling with that now with the Bellamy, because the Bellamy is shaped very steeply. It looks like a large floodplain, but it's shaped very steeply. And the difference in our gauging, because we're gauging of an inch, is the difference of 17,000 gallons a minute. So when we're
and at low flows, the river's running 1,000 gallons a minute, and we're talking about taking 500 out of it. So we're talking
right.
50% of the flow,
Yeah.
where you wouldn't see.
Exactly.
There's a whole different animal here.
Yeah.
Whole different.
So that would kind of determine when you would pump. I suppose you have to do the modeling to figure out how long it would be retained in the aquifer.
Yeah, so one of the things we like is that I think the two basins that are up on the hillside there, kind of back of the napkin again, looking at probably a very high capture rate, 90% maybe. Whereas the one in the lower part, we might lose a portion of the recharge that we put in there. Might not be losses sufficient to make it non-worthy, but we would lose more. But yes, that would be part of the modeling. The modeling that we're doing right now for the Pudding Hill aquifer is difficult. It's good because it helps us. We're dealing with a whole other issue. We're trying to hold back a plume of contamination that's on the orders of 600 and 700 and 800 parts per trillion of PFOA and PFOS, while at the same time recharging these aquifers on the side. So it's got dual purposes.
And that's where?
That's in Dover, city of Dover.
Okay.
And that contamination is from a metals facility. So you have in the state of New Hampshire, it's kind of interesting. We have we're involved in all three of them, three very different sources of PFOA and PFOS contamination. Here you've got the stacks of St. Cobain. There you have a recycled metals facility. And then in Portsmouth, you've got Pease Air Force Base with the firefighting treatments. So all handling it in all different ways. So
as far as like the efficiency of like recharging, so is there studies if we're pumping 1,000 gallons in, we get
800
out?
Yeah, that's what the modeling would tell us.
Okay. So there's no depletion into surrounding areas that is,
Well, we want to make sure we don't flood any basements.
Well,
right.
Well, but further.
It's happened actually, right? I mean,
not yet.
No?
Not that I know of.
But Brandon Kernan, I remember him saying something, I don't remember where, but it was the pond was raised too high and ended up getting into some basements, but I don't think there's anything.
Oh no, that's
around here.
Willen Pond. That's a whole nother. That was that was something we had to come into the rescue to figure out.
Okay.
How do we take groundwater out so that the pond wouldn't flood the basements? And that's, we're in front of those guys on that too. But yeah, that was, so now we've got a municipal supply in that to monitor, to keep the pond level down so that the basements don't flood. But to your point, I think is important is that we would not capture 100%, and I think you know that. And so the goal would be, you know, the cost of pumping that water on a long-term basis would have to be offset. And we haven't found that to be excessive, but we'd have to make sure that we don't lose too much to make it not work.
I'm actually rather surprised it's that positive. I would have expected that there's a lot of water that doesn't end up where we need it and can actually produce it.
Well, in this, yeah, and in Pudding Hill, we are losing more than we would lose here because the topography, the shape of the aquifer, the amount of clay that's present, all plays a role. This one right now looks as if we would have a really pretty efficient system, at least on this, on these two that I've showed you on this side. One of the things though that I want to share with you that because we don't want to, normally what we would do is run a pilot test of taking the water from the river and putting it in the basins and actually monitoring before we build the system, which is what we're doing in Dover. We don't really have the flexibility to do that because we don't run a pipe all the, you know, out to, unless we could figure out a way to get under the railroad tracks and pump it from the river over. What we would do in this case is what we had to do in Newmarket, and that is to create these columns. And I don't know if I have a picture of the column testing. It might be on the back side of this.
Actually, we almost could,
Oh, here's the columns right here. We have a wastewater treatment plant.
there was an outfall in the Merrimack down in this area. That's one of the reasons Jeff and I had walked up that end.
Okay.
So we almost could run a pump, but you'd have to, it'd be a long,
Stretch, you're talking
Yeah.
about
down this side over in here, there was an outfall, there's a culvert that goes out into the Merrimack.
Oh, the one to the north.
Yeah.
Okay, yep.
You cross under the railroad, is that what you're saying, through a culvert or something?
Basically, yeah, you could run up, and then you'd have to climb up a hill behind Parker Village, and, yeah, you could almost do it. But
What color is that out there? What's the length of pipe on that? I can't tell the color. Merrimack 2,800 feet. Okay, so that's a possibility. Now we have ourselves like 1,500 feet of 6-inch pipe that we can just clip together, you know.
They're flexible.
That we use for, it's not 100% flexible, but comes in 20-foot lengths, and they have, you know, that
The
wouldn't be
yellow
a.
mine, yellow mine pipe?
It's not yellow mine, it's actually, it's.
It's Lakeland,
What's
right?
it?
It's in the.
No, it's not,
the
it's
Lakeland
actually,
stuff?
no, it's actually
No.
galvanized pipe, not
No.
galvanized, but it's hard shell. I'm trying to think what it's made out of, but we used it for a number of pump tests where we had to get the water out of the watershed to do it without interfering. And it's actually in Epping's, below their storage tank, in their storage area. But we have access to that. That would be a possibility. And that's kind of the best of both worlds. What we had to do in Newmarket is run columns, which are these things right here, set up, where you run the water through the columns and you take samples as it goes through the column, and these are set up so that you're running the water through and back through. It's not a complicated setup, but it's set up so that we can determine how effective is the aquifer material in taking out the river contaminants.
So you're trying to model the basin substrate inside the column, basically.
Exactly, yeah. And it worked very well. We did it in conjunction with UNH when we did the first one.
Actually, that was 2 columns. One
One saturated,
one
one
was the
not.
saturated zone and one was the unsaturated zone.
Yeah.
And trying to mimic that.
And it's basically core drilled out of the basin or something like that?
Yeah, it was, the samples were taken from the aquifer, and I'm not sure how you got those samples.
One was from drilling and one was from grab samples from the unsaturated material.
Yeah, because you gotta pack those columns at the same density that it is in the ground
Exactly,
and everything.
But, you know, the best way to do it is if we can just pump from the river. But it works both ways. We've done it both ways now twice, and the state recognizes the process and the permitting process and so forth. So at this point, you know, what had been, you know, the next step was to go through, all right, take the information we have, do the pilot test, determine the effectiveness of the aquifer to accept the amount of water we would use. And one of that, we talked about using the hydrant there. So actually running some of the water to waste into the basin for a 30-day test to see how easily the material, you know, accepted the water, and make sure that we didn't have breakthrough and all that good thing. That would be how we would do it if we didn't have access to the river water. So that has to be determined. We'll make a final recommendation as to how, you know, what we would do in this report, but I think that's about it. I don't want to belabor it anymore. It's a lot of information, but you know, I think it's encouraging.
I can turn that on.
The one thing I think it goes to Wolf's question too is, and I think it was one of you, maybe Don, you put it in there, is, so what happens when you have, we did take soil samples, you do have PFOS in the soils. We always find that everywhere we go that the PFOS in the soils is an order of magnitude higher than what we see in the water. And so in these soils you would see something on the order of parts per billion in the soils, and you're seeing parts per trillion in the water. That's gonna stay the same. What we're hopeful, you know, what our goal would be is, and you can imagine, if you start flushing a lot of clean water through, ultimately that's gonna clean itself up. So I don't wanna be as bold as to say this is a great remediation program. But you know, to a certain extent, you are going to be improving the quality of the soils as well in certain areas. Now, it's only a small area because it's an artificial recharge basin. It's not like you're going everywhere. And remember that you're only adding water in one direction. You're taking water in the well screen in 360 degrees direction. So this is a, you know.
Well, you wonder though, where would it go if that would be true?
What's that?
Where would the water, I'm sorry, the contaminants, where would they go?
Well, some of it's gonna retain on the soils.
Right.
You know.
But if we're
and
saying
some of
we're
it's gonna go
flushing
through
them
the
out in this
treatment plant.
process, they have to go somewhere, which
Yeah.
means they were gonna be carried with the water, possibly out, and which then also means we have to then somehow dispose of what comes out of that area first before we can actually even use it.
Well, if you get it, it's gonna go into your treatment plant, you're gonna take it out, it's gonna get caught up in your, and the goal is that instead of treating it 100 parts per trillion, you're gonna be treating it something less than that, because we're mixing it, and PFOA and PFOS are very soluble, so you're gonna be mixing that water.
But I think I would like to see more, you know, discussions about the approval process and the study of that behavior. I mean, who's gonna look at that? Is it gonna be you? Is it gonna be the EPA's or DS? I mean, who's looking at that and who's assessing that for real?
Well, we actually have, right now, we're probably the only ones looking at it in the state, because we're dealing with it in Pudding Hill, and we're seeing, you know, we're seeing changes of hundreds of parts per trillion in monitoring wells in a month. And that's staggering to me.
Reductions of
Yeah, reductions and increases. Now, if we don't have it, we're seeing increases, and we do have it, we're seeing reductions. You know, so it's something that is. I will tell you, there's not a lot of science in it, but I do know that if this is a mass balance, you will dilute, like we will with the sodium chloride. You will dilute the sodium chloride. And that we worked on at one time. Mike and I did a test for well 6 to see if indeed, you know, the blending between 6 and 7 and 8 would reduce the 1,4-dioxane to a level that you could use in well 6. And the blending works very well with 1,4-dioxane, as it does with MTBE, as it does with PFOA and PFOS. That's the one nice thing about soluble, contaminants.
I see you have a test pit 5, which is the upgrading of well 4, but it doesn't look like there's a lot more testing up there. Or is the soil change, does the soil change up there or something, or,
It wasn't as favorable as down in the,
Yeah.
in the test pits down below. I don't have the data in front of me, but.
yeah, okay. I think there's a, I don't know if you guys know where it is, Mike, or I don't know if you worked on this, I don't think you did, but, I think Pennachuck has an intake off the river further downstream. And I think they're pumping it into one of their surface water ponds. Harris Pond?
Yep.
I don't know how much,
They are allowed to take 42 million gallons out of the Merrimack River.
42 million gallons, wow.
That's their permit.
For, how, in what time frame?
Right.
I believe it's about a year.
42 million a year?
Yeah, I'm wondering if they limit you in the summer, there's triggers, low flow triggers and things like that. Would probably be less in the Merrimack than other rivers, I guess, right?
Yeah, as we were saying in the Bellamy, we were gonna have, you know, Q80 triggers probably, or somewhere between Q80 and Q60 triggers. In the Merrimack, that'll be something we discuss with them, but I don't, it's triggered by biohabitats, and I don't think the small amount of water we're taking out of there will have a trigger on biohabitats.
So we'd have to have someone hired to evaluate all that as well, right?
Well, that's part of what we would do, that's what we're
So
doing.
you have that expertise
Yeah.
in-house? All right.
We have the Fish and Game guys, in fact, we have people who used to work for Fish and Game.
I mean, I do a lot of work in Massachusetts, and I know, you know, this, just to determine how much water to pull out of Merrimack River could be a year-long
Fortunately, we're
process,
not in
but-
Massachusetts.
I know, and that's why I don't know if anyone at DES has if you've discussed this with anyone. Have there been any kind of red flag concerns, or is this kind of like seem like it's
Not
something
yet, I mean,
that's
at one point,
favorable?
you know, I brought it up with one person, they said, that sounds like a brilliant idea.
Yeah.
You know, they said, we would be less favorable if you were considering the Babusick River. And I said, well, we're
Makes
really
sense.
not, and, but, you know, I mean, there's a lot of still unknowns about it, and like I said, this is the first test case, and, you know, it's gotta pass the smell test, and right now, it's passing, you know, it's passing my smell test and the guys that were working on it. Clearly, it's got other tests it's gotta pass on your end, and, but I think it has a potential to replace well 3, and I think that's something that I wanna
Yeah.
plant, because, well 3 to me is a significant investment. Forget about the PFOA or PFOS treatment. You've got rising sodium and rising chloride, you got high iron and manganese, you've
Yeah.
got 2 major treatment options that you know, I believe you will not have to deal with here. So how does this go to the next step? The next step would be for us to, well, 3 steps. Us to finish this report sometime probably end of October, get you our recommendations, you guys can sit on it, do whatever you wish. If you wanted to proceed, go to a pilot test next. I would want to get them in there to give us a more detailed assessment of the cost of what that option would be, how that would play comparatively to maybe well 3 or your other options for what you're looking at. If that pilot test proved favorable, then the next step there would be to go forward with the permitting. Or you could go to the permitting, hold the permit. I don't know how long, it's so far, I mean, we're the only ones who've gotten the permits for this, but I'd have to ask and see how long the permit would be able to be held. Probably as long as the large well was involved in this, which would be 5 years, or 10 years.
It's 10 years if it's
10 years.
active, I think 5 years if
If
it's not.
yeah, right. So you could hold that permit for 5 years if you wanted to. I'm guessing that's how they would approach it.
I think what would help us is every possible cost that we think we would have to incur to bring this thing even through construction would be good to know, you know, what
Sure.
pilot tests, just everything we can think of, because really add it all up. I think we all probably have a pretty good handle on the cost of a new source somewhere, a new well source probably.
I don't know. I don't know if we have any resources.
If we
Yeah.
find
That's
one.
the problem.
Well, like for instance, Mitchell Woods, if we're thinking about that, I don't know if we, you know, we have some numbers that we probably are thinking of, looking at, I don't know what they are, but.
Yeah, and that is a permitted source. That is a permitted source.
What was the production rate that we anticipated for that? was just like
It's a small amount, and it's
150,
it's a
200,
couple
something.
hundred
saying
gallons a minute
300?
for
300 gallons a minute.
for something like
350.
120 days a year or something. I've got
That's
to
what I
look it
thought,
up.
yeah.
It's limited
Right.
in terms of how it'd be more of a peak shaving well
Mm.
to help you get through the summer times and then let it recover. It might be 4 months out of the year that you can pump at 5.
So we're looking at possibly an increase of maybe 400 plus gallons a minute at wells 4 and 5, right?
600,000
Yes.
gallons a day.
600.
1,000 gallons a day.
600,000?
Yes, gallons a day.
And
Or-
then,
Okay,
Yeah,
I'm sorry.
yeah.
in well
It's-
3,
It's capable of producing 600,000 now, and that's what you have. The permitted capacity originally was 1.2 million, 1.27 or something, like 1.26 million. So you're looking at, the goal would be to double. That
Right.
would be the goal.
and if we took well 3 off, what's that put out when it runs, like in the summer? That's usually at what, like,
We're right around 800 gallons a minute.
that's out of well 3 right now? Oh, I didn't know it was that high. So basically, we're talking about gaining about.
But that's without 4 and 5 operating at all.
That's true. Okay,
Right, right.
so like well 3 has maybe twice the additional capacity that we could get out of well 4 and 5 with
The additional
artificial
capacity.
recharge.
Well, I would say that well 8, you can't pump well 800 gallons a minute all year round.
Yeah, I was talking about 3. Well 3.
Excuse me, well 3. I don't believe you can pump well 3 365 days a year. Could you? Once Green's Pond water level drops down, the iron and manganese goes off the
Well,
charts.
we,
Yeah.
you know, I don't know. I wanna say we probably could. I mean, the water quality would probably worsen the longer we pumped it, but we typically don't run that. The wintertime use drops way down, so.
Yeah.
Do you use it in the winter?
We don't typically, unless we have to. If well 2 went down for some reason, we could get well 3 online relatively quickly, we would run it. So we're running like our well 3 right now, like we used to run well 8. Well 8, when everything was working, wells 4 and 5 were on. 8 would be, if we absolutely ran into, a real hot summer where the demands were there, we would fire up 8. 8 went years without being turned on.
Right.
I mean, we'd sample and stuff, but we wouldn't put it into the system.
Yeah.
So potentially that's what the well 3 would turn into.
I'm curious too, and I know I mentioned this before about impounding Greens Pond and having that be an artificial basin for well 3. I wonder what the effect would be on well 3 in terms of either yield and or water quality improvements. The only reason I'm thinking about that, it's appealing, is because the cost would be, you wouldn't need the basins and you wouldn't need the pump house and all that for the intake. You would just impound the pond, and I don't know how much water is available in there if you raise it a foot or so,
It's
but.
a good, this has been the $64 question for 30 years. Arlen Jerry, who, I started working when he was here, that's an old name, he's passed away since then, but Arlen would manage well 3 based on the level of Greens Pond. So when Greens Pond was high, he'd pump it because the iron and manganese would be low, and when the Greens Pond dropped, the iron and manganese would increase. And back a long time ago, I actually looked at that data carefully and saw the actual data relationship to it. But the problem was we did take a look at trying to raise Greens Pond, and there was an issue with the road down there and the structure there. And so
I know.
it would take a better man than me to be able to figure out how that gets done, because I'm not a dam guy, but we never really could get to the point of figuring that out. And then you've got the issue with the landowners and the change in water levels on their property and so forth. But it's conceptually, to me, it's a good way to go. If you could make it work. We just never could figure that out. and back when Arlen was, Arlen would just go in and make, he'd build the thing and just get, later.
So was well
Are you
three,
familiar with Arlen?
I heard about it.
Oh, yeah.
was well 3 in before you were involved with?
No,
I
well,
mean,
yeah, well 3 was in before I was involved.
All right, so I was gonna ask you how much of the modeling have you done on well 3, but probably not if it was
Not
already
much,
there.
We did a lot of modeling on well 2 and how to build
Yeah.
well 1 and should we take well 1 off and, that whole thing.
Yeah. Okay.
I remember working on that project, that was before I was a commissioner, but did a lot of work for the district at the time. And I remember doing a map based on 5-foot contour of Merrimack down topo and increasing the elevation of Greens Pond. I don't remember the exact, maybe 2 feet or maybe 4 feet or something. I don't know exactly. I don't know whatever happened to that. I
Yeah.
just know that Alan asked me to do that, and I don't know if the commissioners talked about that at the time, if that's in the minutes, or I don't know if there's any kind of report ever done.
Well, my recollection is that it kind of fell apart at the structure, what's the dirt road that goes across there?
Greens Pond Road.
Greens Pond Road, yeah.
Yeah.
Yeah, Greens Pond Road. Thanks, yeah.
It's like a Greens Pond Road, but a
That's-
green pond.
Yeah.
I also wanted to mention these, back in probably the late 80s, maybe even early 90s, MBD was thinking about taking water out of Merrimack back then.
Right.
And we actually had an agreement, we were gonna buy this longer parcel, it was really 2 parcels of land. We agreed to buy, they agreed to sell the northerly parcel, which would allow us to run a pipe through that to the river. And again, I don't know whatever happened to that. I remember doing the plan for the purchase of the property, and gave it to Alan, and I'm not sure exactly whatever happened to that. We never bought the property, that's for sure.
Well, Ron brought up a good idea about that, is that if at all, and surface water treatment is a whole nother world that you get into, which is a lot more expensive. But if you were able to secure an intake on the Merrimack River, you might keep the area, the frontage, so that if ever you wanted to have a surface water treatment intake, you would keep it, you would have that. That would be kind of another future opportunity for use. I mean, surface water has kind of never been seriously considered here because of the cost, but that's a good point. I want to also mention that Greens Pond used to be treated heavily with copper sulfate to keep the algae down, and so, to my knowledge, it's still done, but I don't know that to a fact. They would add copper sulfate to kill the algae. It was a big issue a number of years ago.
Who was doing that? Someone at the state level?
Yeah, it was at the state level.
Yeah. Huh, I never heard that before.
Yeah, I think it was at the state, but it was one of the things that killed Greens Pond, was copper sulfate.
Haven't they stopped doing that a while ago?
I don't know. They still do it for my black olives, so when we, that's what turns your olive black, is copper sulfate.
Oh, okay. I don't think VES is doing that.
No, they're not doing that, no.
Jamie, one of the things that I had thought about was that at one time I was told, or overheard about, you couldn't take water out of the Merrimack. You had to be so far below, downstream from the treatment plant in Manchester, from Brown Ave. And that was the criteria, and then somehow Pennachuck hooked up and they started taking water out of the river, and then for some reason, I think that screwed us up, and that's why we maybe stopped there or something. There's something about that. I don't know if that's DES requirement, or you probably know more about that, sure.
Yeah, no, I don't think that's an issue anymore. I mean, I can double check on that, but Merrimack, or Manchester itself is now it just finished a 6-7 million gallon a day capacity that our firm, I wasn't involved directly in it, but our firm did, which was an infiltration well with radial wells going out underneath the river and collecting the water through the bottom of the river and pumping out 7 million gallons a day.
Where's that located?
Manchester.
Is it in Manchester or up?
No, it's up gradient.
Yeah.
I think it's probably
Right.
closer.
It's right where the
Yeah.
the 95 bridge, the north,
Yeah,
Oh,
there's,
yeah.
it's by that mall.
there's a commercial mall.
Commercial mall right next to it. Forgot the name of
The
it.
northern crossing of the.
Is that the one where Home Depot is?
Mhm.
I think
Yes,
that-
correct.
right-
Yeah.
right
Oh,
there.
yeah? Huh.
Yeah,
I didn't know that.
yeah.
Can I just tell you that that's exactly what Pennachuck are doing with new intake that's going out in the middle of Merrimack.
Are they really?
Yes.
An artificial, I mean a radial arm well.
There's gonna be 2 pipes.
2 pipes.
Yep, it's just around what they've got right now, which is basically right on the shoreline.
Yeah. So they run that water through a surface water treatment plant, because they don't get the filtration that we get with the artificial recharge.
Yeah.
So I guess, just to kind of summarize, I think, what we're looking at is potential to increase capacity, reduce sodium chloride or dilute sodium chloride, dilute PFOS, use infrastructure that's already in place, use the maximum treatment capacity of the St. Cobain facility, and possibly use it to replace or defer decisions on maybe another source. I can't tell you 100% that it's gonna work yet. I can tell you that the preliminary data says that everything passes muster in terms of potential favorability. I think the state would be, there's nothing that I know of that the state would say, this is not a good idea. It would have to go through the rigorous permitting process. And I think we'll probably be submitting to you a report at the end of October with those recommendations. Next steps would, if you chose to do that, would be a pilot test, and however you decided to do that pilot test.
Does the Army Corps get involved in these withdrawal permits and everything too?
They don't, they have not in the Bellamy.
Really?
Yeah, and in Durham, they already had we're getting a 401 certificate right now for the Bellamy, but.
Okay.
And I, not to raise a sore subject, but I do believe that if you chose to go this route, you could probably get some funding for this. Because I'm working really hard with the commissioner and the commission to respect the need for utilities to be recognized who have had contaminated sources of water. And I will say this, that my testimony before the commission and my input has been, we got the MTB fund because MTB contaminated a lot of groundwater. And I just give you the glimpse of this thing. My partner, Peter Garrett, testified, was the first one to present the professional paper that MTB was going to be a groundwater contaminant, and this is back in the 80s. And CBS's 60 Minutes did a full story on our company and Peter Garrett and the impacts of MTB on groundwater. 25 years later, the state sues ExxonMobil for MTBE. They get money. Exxon decides to not settle, and they go to jury trial, and they end up getting whacked for another 400 million, 300 and some odd million. So that money was put in there for the purpose as a groundwater trust. But right now, a lot of the money has been for concrete and bricks and mortar is what I call it.
Infrastructure.
And I made a complaint to the commission, and they know it very well, that it's okay, I'm okay with bricks and mortar projects, but there's gotta be a groundwater component to it. And the groundwater component should be in helping communities restore their water supply back to their rightful place. And so that has got traction. I actually got emails and conversation this past week from Bob Scott, who's the commissioner of DES, and others, saying, we hear you loud and clear that contamination issues have got to take more of a front role. So I just want you to know that you don't necessarily have to take this on. necessarily as your own expense. I think there's opportunities there for us to get funding down the road, however you want, if we go down the path of contamination. And so I'll leave it at that, and hopefully, that's something that can be considered at some point. Because you're not the only community. I mean, Franklin lost 2 wells from Davidsonville. Peterborough lost wells from New Hampshire Ballbearing. Milford lost wells from the OK Tool Company at the Savage Well, and they never received a penny in compensation for losing those sources. You lost well 6 because of Merrimack Metals. You never got a dime back from that because they went bankrupt. So there are these communities such as yourselves that I think are primed for this discussion, and I would make this very, and I'll share with you my testimony because I put it out, but primed for that kind of money to get back. There's a lot of money there available. So I spoke it too long. Sorry. Hopefully that's helpful.
Yeah, it was helpful.
Thank you, Jamie.
Thank you.
I have to just let you know I'm going to leave about 3:45 because I have another meeting at 4 with Anheuser-Busch. So, I don't know if I can help them or not, but they seem
Okay.
to.
You mean you're going to have a beer? Is that-
No. They have some wells that they use for their cooling towers that aren't working right, so.
Keith, you're up. It's gonna be the 2 of us here, so.
I'm just gonna let you do the whole thing.
You're coming
I guess
up.
I'll move up.
Okay, thank you, and we're here too to update you on where we are on a few of the projects that we're involved in as well, and I think this is maybe I think we had a couple recently too. I know we had one in June, and then we had another one, I think, maybe a month or so ago where Mike went. I couldn't make it, but we were gonna give you a brief update on wells 4 and 5, the treatment design, the study phase work we're doing right now on PFAS alternatives for wells 7, 8, 2, and 3, and the chemical feed improvements. We'll also give you a quick update here on the Turkey Hill Booster Station, because you've got other infrastructure work that's ongoing as well. And then I wanted to come back to spending a little time with you guys today on rates and the financing. And now that we have some things in play, we have to make some decisions on rates and how you want to project or look at some of the alternative impacts for some of the things that we're looking at now. So I've got some ideas, we've got a handout, and then maybe we can close out a little bit on some of the CIP discussions. So there's things we talked about before, even at the last meeting, but I think there's just a little bit more to discuss today. So I think a lot of this can be kept at a high level, and then we can close out on some of the funding and financing. But Mike's got a handout, he's gonna
Do you
start.
guys have this?
They don't.
Okay, I didn't know if it was in the pocket. Mine's not in color. Jamie, you could leave mine.
Mike's gonna speak to it, but I just wanted to jump in real quick. And most of you probably know, and Jamie was just talking about the trust funds, but you've been successful at the trust funds now twice, okay? Once for the Turkey Hill Booster Station, you got the low interest loan for 1.3. And just hot off the presses over the last few weeks, I've been going to every meeting. And, cause we have a lot of projects, including the ones in Merrimack in front of them. But they did support the application that we put in for $405,000. So we had proposed that you would split the underrun CIP trust fund grant. They supported it, they voted on it twice, so they affirmed the recommendation. So they are going to be offering $405,000 in trust fund grant to you to help close out the funding gap that we had on that. So So that's great
Good.
news, that's fantastic.
Yep.
So it's due to the efforts of all of us, I think it
Thanks.
came together, so. So Mike, go ahead.
All right, so this is a status report, kind of summary of where we are with the various projects we're working on. So I'll start with well 4 and 5. Oh, gotcha. And just going down to things that have to be done or that we're working on, there's some additional field work, the additional survey for the sewer connection that will connect to the town sewer that runs down the railway line. And I don't know if that's actually happened yet. I don't know, Chip, are you still tied in with those guys with Fieldstone? I know that they were scheduling this, but I don't know exactly if they've gotten out there yet, so, but they'll be doing that work. And then we also had budgeted to do some test pits along that line down to the sewer to, excuse me, so we know what subsurface conditions are. In talking to some of our engineers who are working on it, they think that might not be necessary due to the fact that it's all sand and gravel. So, but right now we have that budgeted. And then the next thing you see there is the RSSCT. That's the Rapid Small Scale Column Tests, also known as accelerated column tests. And that's what we have been talking about, getting samples of the water from the wells in order to run those tests. The whole purpose of those tests is to do a accelerated, try to get the breakthrough of the GAC, so we know what the GAC life will be, and also we have a better handle on what it's actually removing. So where that stands is we now have sitting in our office about a dozen coolers that are about that big by that big that we had shipped from the independent. Now this is an independent lab. It's engineered some performance systems, EPS. And the good thing about that is that they're not tied into any particular manufacturer or anybody. They're independent, so they don't care whether it's a Calgon product, a TIG product, or whatever. And so we'll get the results from them. So we're in the process of doing that. I got to coordinate with Ron, where we're going to put that water and where we're going to draw it from, and we've had some discussions about whether we need to make like a little hay bale enclosure with some riprap or something, because we're going to be pumping at a decent rate. So that's something I want to coordinate with you on and just see where we're going to put that water. So that's in progress. In terms of the design, I just wanted to hand out, let's see, more handouts.
Want me to do that?
Yeah.
While you're talking.
Oh, some of those are other things, so.
All right, well, I'll just keep on.
So Keith's gonna hand out what we've done, and this is a work in progress, so when I had the engineers prepare this, they wanted to make sure they understand it's a work in progress and things can change, but. So this gives you sort of the overall, the first one is.
Yes.
The first one is the existing conditions at the site. So that's what it looks like now. So you can see where the road comes into it from Front Street and then turns and goes by well 4 and up to well 5. That sort of road that looks like it loops around is very rough right now. It's a very rough track if you've been out there. All right, and then the next sheet is a preliminary site layout of the building, and you will see that the building has changed somewhat from where we started. I think the original building was something like 60 by 44, and then when we worked through the process with St. Gobain and their consultancy team Mail, we tried to reduce that size down to around 58 by 51. Just in terms of looking at the layout of this building, and that's on the next sheet. Right now we're talking, I believe this structure is let's see here, is 83 by 34, roughly. So that's but, before I get to the actual, interior layout, on the exterior layout, we're looking at it this way. Our guys met with Ron out on the site, and Ron was expressing an interest in using that loop road for truck traffic. So trucks could come in, deliver chemicals, and then continue around in a circle and go out. We'll have to think about that, because when we eliminated some of the site work in order to reduce the costs, we were doing, going through the negotiation process, and that's one of the things we eliminated. So, just, we'll have to see how that works into the whole cost structure. Also, one of the things that would be somewhat different than where we started is, Ron has expressed an interest in just getting rid of the old well 5 building and moving everything from there into the new plant. And we were gonna get rid of the the lime station anyways. That was in the plan.
Mike, where's wells 4 and 5 on
So, let's see, I'm not exactly sure. Let's go back to, so, if you look at this one, the overall, well 5 is right on that building, the well 4 is in that building.
Okay.
All right, so if we flip to this one, then it's gonna be, is that it? Yeah, raw water.
Is that what RW is, or raw water?
Yeah,
What's FW, finished water?
finished water. So that's coming from well 5, where's that one coming from? Well
I don't
4?
see well 4, the building isn't drawn on.
Yeah, I don't see it either. That's why I think she was cautioning me to say this is a work in progress and it may not be complete, so.
Right, that roadway right there.
It's probably where that little turnout is.
You're
there.
right.
Yeah, that little turnout is where it would be. And then you can see, and I was listening to Jamie with interest on where your recharge main would come, because I think it's coming up the same road that we're running the sewer down to the,
Yeah.
that Woods Road there.
And thank you for keeping it off the area of the basins.
And on this, the basins, I wasn't looking at your figures, they're up in here, right?
Right, right.
Oh, and the other, they're over here? Oh, okay.
No, you were right.
Okay.
They're to the left, right?
Yeah, right.
Up on that knoll, you said, right?
Correct.
Right, because
Oh,
this,
really?
yeah, that's that flat area up there on top of that knoll. Because if you get too far this way, you're into the gravel pit, start dropping off.
Okay.
So that's our current thinking and where we're at now. And then in terms of the building layout, that third sheet, we've got all the components that we need for this, that we think we need for this treatment plant. You've got the GAC filters, we've got the chemical feed facilities for sodium hydroxide, which replaces the lime. Right now, we're showing calcium hypochlorite for our disinfection and chlorination, and blended phosphate. So everything that's being fed right now, and we've got to just coordinate with Ron and Kevin on whether we're going to use tablets or sodium hypochlorite. So that I know Don knows. Sodium hypochlorite is a liquid. Calcium hypochlorite are tablets. And for quite a while, you guys have been using the tablet feeders, but we did switch to liquid at wells 7 and 8 for the oxidizing of the iron and manganese at the treatment plant down there. So we could go either way. Right now we're showing tablet chlorinators. And we're showing a future area where, resin contactors, filters could be added as well. So that's sort of the current layout.
So what is the treatment sequence here? It's just coming from raw water and going into the carbon filters first?
Yes, it would be. It would go through the carbon filters first, and then,
So it'd be lead lag filters, right?
yeah, they'd be the idea is you have lead lag filters so that you're measuring the
In between the two.
the PFOA, whatever, the PFAS, let's say, use the broad term. At points through at sample points through the vessel itself, as well as
Right.
the midpoint between the two, And when you start to get an increase, and you can set it, but, you know, a rule of thumb that some other people have been using is when you get to half of the influent level, then you take that one offline, you replace it, you switch the other one to be the lead.
Now,
and
you
replace the carbon.
you'd be able to do that with valving and piping here? You wouldn't physically have to move the filters around?
Oh,
right?
no, these filters are, I mean, and that's something we've been wrestling with a little bit, because typically when you're doing a treatment plant and you're putting the filters in, you try to make some way of taking those filters out of the building if you ever need to.
Yeah.
These things are so massive that trying to accommodate that would be
Yeah.
cost prohibitive, I think.
So they're how long, like 20-something feet tall?
They are
or-
12 feet in diameter, and they are 26 feet and change tall, between 26 and 27 feet tall.
Two of them?
Two of them.
So you have to bring those in before the building is erected, right?
Yeah, you would probably put those in and then put the roof on
Foundations in,
afterwards,
yeah.
yeah. Go ahead, Joe, I'm sorry.
They don't come apart, they're like one unit?
Yeah.
What does Budweiser do when they get about 150 of them now? They're 3 times as big as that.
I don't know, Jamie, could you find that out in your meeting?
They build them on site, actually.
They build them on
The
site.
Cherry Burrell company comes in and they physically fabricate
They
them.
weld them and all that?
Yeah, in situ.
And probably never have to
inside.
move them,
Yeah.
right?
They did 182 of them down at the Newark facility there when they did an expansion.
So that would come out of the carbon filters and go,
Come out of the carbon filters, let's see, I've got to follow this myself. So you got the filtered water, which is headed out. We wouldn't have a clear well here, because there's really no need for backwashing other than when you initially put the filters online or if you change the filter media. So after it leaves the filters, it's going to get injected with sodium hydroxide and with calcium hypochlorite, and the blended phosphate for that's got a dual role. That's for corrosion control as well as any sequestering of iron and manganese that's in there.
and what is that? Is that polyorthophosphate?
Yeah, blended
It's blended,
phosphate is
yeah.
a mixture. Do you know the percentage you're using? Okay.
It's usually low on poly, right?
It depends on what you're doing, because you can get it with anywhere from, let's say, 30% poly and 70% ortho to the other way around. And orthophosphate is generally used more for corrosion control because it's a film former, forms on the inside of metal pipes. And the polyphosphate is more for sequestering because it has a habit of grabbing onto those divalent metal ions and tying them up. So that's, I didn't want to get too much into the weeds of it, but that's a general idea, and that's where it stands right now.
And we still have an outside generator on here?
Yes, there's an outside generator, which I don't think we're showing at this point. You know, we got to figure out where that's going to go and so forth. But yes, that was one of the ways that we reduced the building size. That was the main way that we reduced the building size before, from version 1 to version 2, and now we're on version 3. And these things have a way of, you go through and you go, okay, this works, and then as you get through the process a little bit further, you find some roadblock, and maybe you have to change the dimension of one, a foot here, a foot there. I know we went through that with the well 7 and 8 building. That started at like 30 by 50 and ended up at much bigger than that. So, but actually this, I was worried when they told me what the size they were coming up with, because of the whole exercise that we went through in reducing the building. But right now, this footprint is the same or smaller than my 58 by 51. At least when it was 83 by 33, that's a smaller square footage than that. So that's where that stands at the moment. We just put the budget in here, and it's 4.16 million with 3.35 million coming from St. Cobain, 400,000 from capital reserve, and 400,000 from the trust fund to be successful on that. And Keith talked about that. In terms of the schedule, You know, we signed the ESR, that's our contract, that was signed in March of this year. Funding was secured both in June and then in the August or September round of the Drinking Water Groundwater Trust. 60% design, we're looking to be done by November 1. 90% by around February 1 of next year, with a bidding target in March of next year. So that's the current schedule. And, you know, next steps, trust fund application, we'll be working to put that in on your behalf. And I didn't put it on here, but one thing that I know has been brought up before that I still want to do is arrange a trip to go over to Hoosick Falls and see what they have there and talk to those guys. So if and when I do that, I just need to know who here would be interested in going to that. We've already been spending time over at Pease, looking at the ones that they have online there, and that's helpful to be able to go 45 minutes from our office, or an hour from our office, and see two, those are 10-foot diameters, but they have all the same piping. And this was something that, I can't remember who said, but are we gonna gain from the experience that these people have, and that's our point. So we're finding things out like with the GAC that when you initially put it online, it has a habit of pH, like as high as 9.
Wow.
You know, once it starts going through the GAC, and then it takes a while for that pH to drop back down. So that may change our thoughts on how long, you know, do we need to pump to waste, you know, so that initial backwash for a while. So there are
That's pretty aggressive.
yeah.
You probably want to kill the sodium hydroxide for a little while.
Yeah. So you know, these are things that we're finding more up, you know, and you get into the weeds of the thing.
Would it make sense to bring Kevin or somebody from the floor for design review into these things?
That would, we definitely will, yeah.
Oh, yeah. When we did the well 7 and 8 plant, we took Kevin, Ron, we took everybody.
Okay,
Dave,
good,
yeah.
good,
Yeah.
good, yeah, good.
We took Kevin, Ron, Jill, Jill's mom, we took everybody.
You looked at a couple plants then too, didn't you?
We looked at Dover and Seabrook
Yeah.
on that day.
You bought dinner, I think.
And we probably bought dinner and,
Had a big van or something.
yeah, so, I mean, and we can do something similar to whoever who would want to go to whatever plants that we would look at. But right now, there's the one in Hoosick, and I'll see what other, I know there are others in the works in Mass.
How far is Hoosick from here? Is that like 4 hours?
From here, no, 2.5.
Oh, is it?
It's right on the Vermont border, so.
Yeah, it's not too
Okay.
far over.
Yeah, that's right, it's right on the other side, right?
Right on the other side of,
The 2.5, have you driven there from here?
Bennington?
Yeah.
Well, my parents lived there.
Oh.
They did live there, near Hoosick.
Okay.
It's Bennington's in the Vermont side, is that right?
Yes.
Yeah.
Yeah.
Yeah, it's right near Bennington, yeah. So that, I didn't put that on here, but that's something that we want to do.
About when do you think when that would be the appropriate time to do that?
I haven't scheduled it yet, so, I mean, I'm totally open to when that, but I would say within the next month.
Yeah.
Yeah, because you
Now,
want to
yeah.
get information from that to finish the design
Yes.
you're doing, right?
Yeah.
Yeah. Right.
And I know we've been in touch with them, and they're very receptive to sharing their experiences and what they've done.
Right. Good. Yeah, I think you had contacted the same guy that I sent an email asking him the same, if he'd be interested, you know, talking to us, or.
Yeah.
And you already talked to him, so.
Yeah,
Yeah.
he's definitely very forthcoming. It's, you find, I mean, my general experience with anybody who gets a new treatment like this, and they're dealing with something, and they learn all this stuff, they're almost eager to share what their experiences with you know, and tell you the pitfalls that you've run into. And that's, you know, so this change in pH is one of the things that we're talking through with Al Pratt over in Portsmouth. And we will continue to mine them for information. All right, any other questions on well 4 and 5 at this point? All right, for the PFAS, no, I don't know what you passed out. Did you-
Only the 4, 5, so.
Oh, okay.
You
So
want
for
these
the,
out now?
yeah, you can do that one.
Do you need it? Do you need it?
Yeah, leave one here. So these are just some preliminary drawings of what we would envision the GAC units, if we were using GAC units at well 7 and 8, what they would look like. So while he's doing that, so we had to determine, and I talked about this at the last commissioners meeting, you know, we've assumed a target of non-detect for any PFAS analyte. So that's where that's the treatment target. And we concentrated on 7 and 8 first because that was the highest PFAS loading. So when I heard Jamie say that it was 3, I made a mental note and said, I don't think it's 3, I think it's 7 and 8.
Yeah.
But and if there's the existing treatment plant to work from. So at this point, you know, we have costs on the GAC and the resin treatment. We've got preliminary layouts in progress. And you know, once we get that to where we want it to be, then we will be developing the costs on that. So on this thing, you know, this shows sort of the grayed out light portion on this 11 by 17 plan shows the existing plant and where we would add on for this. And we're showing 2 12-foot GAC filters and future GAC filters, but that could be future resin too, that, you know, those big circles. So it doesn't, you know, that's just what they drew, but that's what that space would be used for. And then also, as I talked to you last night at the commissioners meeting, because of the height of these filters and the change in the building roof line that would cause, you know, we're looking at depressing the slab for these, and then so that would just mean a increase in roof size or height of maybe 1 to 2 feet, and then you have a catwalk in between, so you get to the doors that go out the back. So there'd be kind of 2 levels, like a mezzanine catwalk level and then the basement level.
About how depressed, how far down would that be? Is that like 8 or 10 feet? It looks like you got a lot of stairs there, so.
Yeah, let's see, well, we got 192
I don't see it.
on the slab at the bottom, and we've got elevation 203.5 at the top of the grading.
Right.
And what I'm not sure if that matches the floor elevation of the existing plant. That's what I need to check. That's my assumption.
So it's about 11 feet if that's the case then?
Yeah.
Can you talk, Mike, do you recall, this was an area that was designated for expansion anyway?
Right.
On site, did you talk about that?
Yeah, I talked a little about that at the commissioners meeting, but I'm happy to do it again here now. So this area is the area that was dedicated for expansion of the iron and manganese facility. We were, you know, as we worked through this, you know, Emery and Garrett was working on potential sources that were across the brook that could be piped into here, and they had high manganese. No, did they have iron? I know it was high manganese.
High manganese, yep.
Yeah.
That's the right farm.
Yeah, so that's the right farm property, and so that's kind of what we had in mind, or whatever future source we might need or find to bring in there. I kind of went through the ground densification process that we had to do there, ran aggregate piers because of the fine nature of the sands and that they could liquefy in an earthquake. And so that whole area there that's in the darker part has been prepared and was prepared for an expansion of the iron and manganese plant. So if we use it for PFAS treatment, then obviously it's not available for additional iron and manganese capacity. But the good news is in terms of if you want to put an addition on for PFAS, that's a place that's already been prepared for it.
Excuse me, Mike, just real
Yep.
quick, if you were to put Wright Farm on there, would this be, you would eliminate Wright, I mean, maybe we have already, but Wright Farm could not come into this?
Well, it
in
could,
future?
yeah, I mean, sure, it could, but we wouldn't be expanding we wouldn't have additional green sand capacity to treat that.
Got it.
It would just be one more,
Would be an either or.
it would, one more tool in the toolbox that we could use. We could use 7, we could use 8, we could use Wright Farm.
Right, got it.
Are all of the 4 green sand filters now in use?
Yes. So that just gives you an overview of where we're at on sort of the layout of this. And I know one of Don's questions that he asked us was costs, and when I got back from the last commissioners meeting, I told the engineers I had working on this, I need costs for the next commissioners meeting. I didn't tell them I needed costs for this meeting, so, so I will have costs.
It's your fault.
It's my fault.
Okay.
I'm guilty of that. And then, Keith asked me, hey, we got any, updated costs? And when I went to Lynette, said, no, we got any updated costs? She says, you told me the 17th.
Yeah.
I went, yeah, I know, okay, just checking. So, we will have those for the next commissioners meeting. And 2 and 3, we're still gathering costs, so we've got GAC and resin treatment costs coming in. And everybody's busy, so I know that at least one of the resin guys said, how soon do you need it? And the earliest he's gonna get us something is on the 12th. And that gives us some time to work with that before the 17th. We've also sent out a RFP for iron manganese treatment, for well 3, because well 3, that's part of our scope, is to are we gonna have a combined iron and manganese PFAS treatment facility at well 3? This could be impacted if the AR goes forward and we don't do something with well 3, but right now that's what we're charged with, so we're getting those costs as well. Once we have all the treatment pieces, then we do the building, sort of like we have here for 7 and 8. We do some kind of layout so that we have something on which we can base costs. And again, my goal is to have the preliminary layouts and costs on that by the 9/17 board meeting. I'm supposed to be at the New England Water Works meeting that day, so we'll have to figure out what's going on there.
Could be Lynette and I.
Yeah. So.
I do have a question.
Yeah.
And you probably talked about this last time. Would we have to repipe? So the flow, the raw water would have to come through the GAC filters, right?
No, we go through the iron and manganese filters first.
Right.
We definitely go through, we want to take out as much as possible with the iron and manganese, with the green sand, before we get to the carbon.
Okay.
Because, I mean, the green sand, we can backwash, and, once head loss builds up, we exhaust the carbon, now you gotta replace the carbon.
All right.
Okay, so and the piping is a little bit of a shooting match.
I thought chlorine did something with the
Chlor-
filters, though.
It does, that's chlorine, so that's one of the reasons we're looking at GAC here instead of resin as a lead, because we have to feed chlorine in order to oxidize the iron and manganese, and right now we're carrying a chlorine residual when we come out of those filters.
Right.
If you go onto resin with a chlorine residual above about 0.2 milligrams per liter, you're gonna cause those resin beads to expand and actually break.
Okay.
So that's kind of why we're looking at the GAC as the lead. Then resin could come after that, because GAC will also take out chlorine, but it doesn't hurt it, like it can for resin.
Would that exhaust capacity of the GAC, the removal of chlorine?
It would add to it, yes.
So that, yeah.
So you don't want to go on there with a lot of chlorine.
Yeah, right.
And I mean, you could start operationally, trying to feed your chlorine such that you get the oxidation of iron and manganese you want, and when you get to the end of those filters, it's 0. But that's hard, that's, and it can fluctuate.
Right. Yep.
All right. So any other questions on that at this point? Okay, moving on to the next thing we're working on, chemical feed and building improvements at 2, 3, 7, and 8. Pete Pitsis, who's an engineer, works with me in Concord, went down to look at the well 7 building as to where, this is the temporary feed of caustic to sodium hydroxide to replace the lime feed at the water treatment, at the well 7 and 8 water treatment plant. So he went down to look at that, had some discussions with Kevin down there, and we'll be continuing those with him. And then we want to set up a site visit with our structural engineer to come down, and that'll be to look at all the the well buildings themselves. Because the idea there is these buildings haven't been upgraded in a while, you know, do they need structural improvements? Do they need roof improvements? Are there issues there? And so we want to bring these things up to snuff, or what the cost would be to bring them up to snuff. And we've just done a very similar thing in Dover. So when I say next steps, arrange site tour for MDD to view other upgraded chemical feed pump station installations, that's kind of what I'm thinking, is bring you over there so whoever wants to go, so we can see what's been done there, and you can either go, yeah, that's what we want to do, or no, we don't want to do anything like that, you know. So we want to do that soon as well.
Mike, I just had a question about, do you
Yeah.
ever use potassium hydroxide? Is that more expensive than sodium hydroxide?
I have used potassium hydroxide.
Yeah.
Used to use it in Mass all the time.
That's why I see it all the time in
Yeah,
Mass.
yeah, when I was, and that was because, when we were doing all the corrosion control work in a lot of the corrosion control work happened after the lead and copper rule came into existence. And there were the action limits on lead and copper, and that was in the early 90s. And Mass, more than New Hampshire, was very, very goosey about adding sodium to the water.
Right, that's why I was asking. I mean, I don't know how much sodium it would add, but if it's immaterial, and I don't know if
It
one's
adds
more
some, and we can
expensive.
calculate that. It's a
Yeah.
stoichiometric, you know, calculation that you can figure out. And we've done that, and so, but because of that, and Mass was saying at the time that if you were over 20 milligrams per liter of
Right.
sodium, because of that American Heart Association standard, that, you know, you had to notify anybody on,
Yeah. Low sodium diets.
yeah, low sodium diets with high blood pressure, that sort of thing. And most of the systems that I was dealing with in Mass at the time said, let's go potassium hydroxide so we don't have that issue. One of the problems with potassium hydroxide is it tends to crystallize at, I think, like 53 degrees or 50 degrees, something like that. So that there were problems with it, on how you store it and making sure you kept it warm and not crystallizing. And so the sodium hydroxide was a more forgiving chemical than potassium. I'm not adverse to using it, and we can look at the cost. Certainly sodium is an issue here.
Okay.
Okay? So let's see, so, and again, the goal here is to get the temporary sodium hydroxide design set up by the end of September, and then get the building improvements technical memo by the end of October. So we've got a lot of stuff that we're trying to get done in the next few months.
And that'll replace the lime shaking systems and all that stuff.
Right. Right, move away from the line, get rid of those little
That was,
precast things.
wasn't, you think the lime might be masking the green sand filters at well 7 and 8, possibly?
Yes, that's been what we've been told, is that the lime has been plating out on top of the green sand filters and causing early, you know, and quicker
Pressure
head
buildup,
loss.
yeah.
Therefore, you have to backwash more frequently and more, which is not good, so. Every time you
Okay.
backwash, you are wasting water. Well, you're putting water
Right.
somewhere where you can't. I mean, we have recycle there, but, yeah, that's the idea.
So that's probably more of a priority at 7 and 8.
That's why it's a short-term, get a preliminary design, and the idea is that we give the preliminary design to you guys and you put it in.
And you have the money budgeted for that, that's budgeted.
Okay.
So that's in play, the intent is to get that done. What was it, 170 or 100, somewhere around there,
That's in
190?
here already?
What's that?
That's in here?
Yep, and it was in your FY19 budget. I'm 90%, 99% sure. But it's on the CIP, it's on in maybe a third of the way down or something. Should be 190 or
170.
maybe it was
Oh, yeah, I see
170.
it.
Is it there?
Well 7 short-term, long-term improvements, lime
What's the-
study,
Yeah, what's the number?
190.
Yeah.
Okay. So is the evaluation, the
Oh, okay.
20,000 in here is what you guys are working on?
Yep, yep.
Okay.
Okay, Jamie, thanks.
No, thank you. Just real quick on the, I'm just gonna say to Mike, on the well site monitoring for Mitchell Woods, of course, we've got that permit, we've got long-term groundwater monitoring that has to be done. That's an annual thing, so we'll be coming back to pick up the next year in January for that. Then I was thinking if they are working on the cost assessment. You gotta get a cost of what it takes to hook up Mitchell Woods. You know, just so we know, we've already got the thing identified as permitted, it's out there. You know, where does that fit into the options?
I think we did that, right?
Maybe
We did a cost opinion
something
on
like
that. Yeah,
Pretty
so-
sure we did.
Yeah.
Thank you very much, appreciate it.
Thank
If you
you.
have any other questions, don't hesitate to contact me. I won't be here for the 17th. I don't know if I was invited, but.
You can't come anywhere.
Well, you're not now.
Actually,
But
David,
thanks,
David,
anytime.
could you email us whatever you had on these posters here, because we didn't really have a chance to go through the detail.
Email it.
Is that
I just
something-
had it for pictures so you could see what it would look like, that's all. But if
Well-
you would like me to send some pictures so you can send them.
Just
to you-
those graphs and those,
Yeah.
I would like to see a little bit
No
more.
worries.
Thank you.
Thanks.
See you,
Thank you so
Jamie.
much.
All right, so actually I've gotten to the end of that. Are there any other questions on the chemical feed building improvements?
The 190, that's for wells just 7 and 8, right?
Right.
Yeah, that's for implementing the.
All right, so the priority's kind of already baked into this, obviously. Good.
Right.
I'm catching up to you guys.
Yeah, good.
Then you're gonna pass us, and I don't know what we're gonna do. So then we get to the Turkey Hill Booster Station, and I flip it back over to Keith.
Tom is working on that one at the office as well, so I have a quick update on that, but just quickly, that's a $1.3 million project, as you know, voted in by the town at your annual meeting. The applications went in, Governor and Council approved it, so that funding's all secured. Field work, survey work is in progress. The subsurface work is done, we already drilled out there, so the soils look, no surprises, we're comfortable with what we saw. I don't think we have our geotechnical report yet, but the preliminary indication was there's no surprises and there shouldn't be an issue. There will be a couple permits that we'll be involved in. Shoreland will be by notification of PBN. I think we're gonna do some courtesy planning board reviews with the town to make sure that they're comfortable with what we're proposing. As you recall, it's a pre-manufactured building that's gonna go in adjacent to the existing station. We'll have an external generator. So it'll be kind of a come in, plug and chug, put it together.
And it's all above grade,
All above grade now,
so that whole pit is gonna be eventually
abandoned,
decommissioned.
decommissioned. Yep, it'll all be above grade.
Is Shoreland because of the proximity to the
That
Southeast?
stream there.
The stream is, that's not the,
Little brook that goes through.
yeah, there's a brook there.
Oh,
What's it called?
I don't even know what has a name.
Yeah.
Oh, okay.
That I'm aware of.
Yeah.
It's just that little thing, that's the
Yeah.
purpose for that, right?
okay.
And again, similar schedule to wells 4 and 5 with the spring bid and construction next year. So that's just a quick update. It's much of what we said last time, so there's really nothing new here. Any other questions on that one? Oh, one new thing on it, and it's noted here, but Tom mentioned it. I think last year when we were doing the tank work, Ron, we only got to the recoating of the tank, but we didn't get to the mixing of this tank.
Right.
I think partly for timing and budget reasons, but, you know, we believe that work that was delayed last year could be it's already designed and ready to go, could be wrapped into this bid and maintained as eligible. So it's something we can talk to.
Putting a mixer in the big
Yeah.
4 million gallon?
Yeah.
Not so much the mixer, but it was the electrical work anyways to get ready for the mixer.
Oh,
But if
Yeah.
we can get it all in, it would be great.
Yeah, so maybe we can talk about bidding it as an alternate, and if the funding allows and the budget allows, it could be wrapped into this work. So it was just an option that we were exploring, so it may be something we'll explore more with you as we get closer to bidding.
And now your favorite topic,
Rates.
rates.
Okay, last time I was in front of you, I just did a quick update on rates, but I got a little bit more I want to share and talk with you if you're ready to jump into it. Joe says yes, loves rates. It was in 2011, 2014 was the last time we did a rates recommendation for you.
I did
And there-
review that, by the way.
What's that?
I did look at that.
Excellent. Here's a copy of it here. The rate recommendations that were made at that time were not implemented. So there was some recommendations to adjust the rates to deal with primarily the debt service coming online with 7 and 8 treatment plant. But I think the idea was there was some new things coming on, there was running a little bit of a surplus, let's see how it goes. And so the rate increase and adjustment recommendations were held off. So there has been no rate adjustments in 2011. The last time the rates were adjusted, which was also based on a rate model we did 2010-ish. We were then put under contract about a year and a half ago, 2 years ago, to do the rate model update, which is, it's essentially drafted. You guys have not seen it, but it was held because there was a lot of things up in the air. There was 4 and 5, there was Turkey Hill Booster, there was a lot of significant costs coming up. We had to get our hands around what those funding scenarios would look like. So we just, let's just hold on it. We were able to get by into the existing rate structure with the existing surpluses. So we didn't complete it. We're now ready to complete it. So we're, based on the final funding packages that came in for wells 4 and 5, Turkey Hill Booster, we know what the rates and the terms are on that. We can now make rate recommendations for you for this. We also are in the position where we really have to, because I think in talking briefly with your staff and Michelle, your surpluses don't exist anymore. You know, you got some line items that are increasing. You're covering the debt on 7 and 8, but no longer are we at the point where you're running in the black by much. So we do have to make some adjustments. So if you look at the handout, we want to do some rate recommendations for you. I'm calling them baseline recommendations. So the baseline rate review is needed to support the following projects that are not currently built into the rates. Starting on the top of page 3. Line item budget increases. You know, we're going to do that. There's been budget adjustments over the time. I think there's been some new ones and then some adjustments. Michelle was telling me a little bit about some of them, from healthcare premiums to water purchases and some other things that are in there. So we're going to get ourselves up to date on where you are with line items. Our model, by the way, just as a reminder, projects 5 years forward and looks 3 years back. So you have a 3-year history with a 5-year look ahead. So it's a nice capture of where the finances stand. It's not, I also tell people, it's not an accounting tool. It's a, you know, in equals out tool. So we use going forward and look at actuals going back. So sometimes they don't always line up with your financial reports, because that's sometimes based on when money actually comes in versus what you truly budgeted. But it's a good representation of what you need to raise for revenue to meet your expenses. So we're going to look at the line item budget increases. We're going to make sure we've captured well 7 and 8 debt. The debt service is now established and your payments are established. We know where you are with wells 4 and 5. The only thing that's impacting you in terms of an expense on that right now is going to be the part we take out of the CIP, and then the part we need to operate it. And so those two will be built into the rates. And then the Turkey Hill Booster Station debt will be built into the rates. So we're looking at that as the baseline right now, as to what we probably need to do just to maintain where you are. We're talking about, and then our model is set up to run some scenarios and say, okay, that's baseline. We have our rate structure sheet that allows us to look at all options or scenarios or things that you're considering. And the ones that we've been talking about, I'm looking at are on the CIP. So this is where I'm going to need feedback and discussions, and you may say, okay, run these. We'll see how the rates, what it looks like on the rates, and then we may want to decide whether we're going to build it into the rates or not. But if you tie things into the CIP, we do have a new well site that's been sort of on the books for a while, and well level monitoring. We have the future potential, and there was a lot of discussion on both these tonight. Wells number 3, iron and manganese treatment plant. And then we have what we're currently working on that's actually not in the CIP, are things for potential PFAS treatment at wells 7 and 8 and or wells 2 and 3. So I think what we would suggest as start points is we can run rate adjustments for the baseline work, and then do a rate scenario for each one of these 3, and just say, okay, here's what it would be if you do this one, here's what you do if you do this one, here's what it would be if you do this one. And then we can sort of add them together too, if you want to do 1 and 2 or all 3. So then it gives you a tool, or at least a planning tool, to say, okay, if we're really seriously looking at these things, this is what it would probably do to a rate structure.
Makes sense.
Okay. And I know a lot of these things tend to be moving targets, but that's why we do the baseline rate adjustment, because you have to do that. And then the other ones are planning tools as you're looking at capital needs or capital options.
Michelle, surplus? What we consider surplus is net income, right?
Pardon?
Net income is what we consider surplus, or what are we looking at as far as, when you say our surplus is now?
When we look at it, and we look at it going back, so we our rate model, and we try to reconcile this with your guys', but we look at where your actual expenses were to your actual revenues, and look at the surplus going into reserves. And so that's how we project forward. So when we track our model, we do the same thing projecting forward. So if we're gonna try to run in the black, we show that any surplus goes into your reserves. So you see either growth in reserves or a decrease in reserves, depending on what we also pull out for the capital needs. But that's just our way to show that it's an increase or a decrease in your revenue.
So we're looking at the current year, well, the one that we just closed, July 18th, we look at $1 million?
No, actually, right now we haven't finalized, so we still have a lot of.
Right.
There's still quite a bit of entries to be made for adjustment,
Right,
so
we had
it's
said
not.
last time there's about 40,000 from inventory and that are actually coming in, and 69 that are going out from the well cleaning, right? So all in all, it should be around,
No,
net income should be
the
around $1
surpluses
million.
we're looking at are against, just the budgetary items, not the pure accounting, standard accounting. It's gonna go against budget, how we were against budget, so it's, before the, other revenues and expenses, so the one line up from the bottom line net income.
Right.
So there we
But
were
bottom
running.
line is that MVD as a business made about $1 million in net income last year.
But as far as how they're looking at our surplus, that would just be from where we were against budget items, not against all the, as I said, the other inventory, other income and expenses. So we're not gonna see the surplus for this purpose is not gonna be in that range.
I think what we're seeing, and we still have some work to do with your staff, but just based on some initial discussions, you historically have been running a surplus of about $500,000, plus or minus.
Okay.
That's been going into reserves until this year, where we're seeing, I think that FY18, we don't see any, zero, or plus or minus.
Yeah.
You know, I mean, maybe a little bit, but it's not the $500,000 that we've seen historically. But there's reasons for it. We have $250,000 in new debt for well 7 and 8. There's half of it, right there.
And our legal fees were
You had
a
some
lot
legal
higher
fee
than
bumps, you had
We
some
had
water.
four or five expense line items added up to over $200,000.
Yeah, and
Over
with,
budget.
and with the 7 and 8 debt, which was about $260 a year, there's $460 of it right there. So it made sense.
Yeah.
And because we hadn't done a rate increase in advance of it, we knew we could sort of get away with it for a little bit of
Right.
time, but we have to
catch up at some point.
We have to catch up now. So that's what we're proposing to do. I think in terms of a time frame, I think the books are gonna be closing soon, or you're gonna close your own books soon?
We've actually already had the audit field work,
Okay.
so I would say I should probably finalize my side of entries with them in the next couple of weeks. And I would, say sometime in October. We should have numbers that we can look at for the rate study purpose. As far as the complete report, that won't be until sometime in November.
And I think this all lines up well with the dollar numbers that are coming in from the capital sides of the studies. So as this stuff, we can then look at probably some rate findings with you in late October, early November, something like that. But I think in our mind, we're gonna have to have a rate adjustment in play by no later than the beginning of January, you know, for that, if not sooner.
So you're gonna include like you said, this, the stuff that's already in the CIP as a base?
As a scenario.
Right.
Yep. Yep. And you can see on the bottom of the CIP, and this is where, you know, I think this is what we did last year, but we look at this every year. You see the top 3/4 of the CIP is what's being spent, what's going out. That bottom third of the table talks about where we want to take it from. And so that's important because that's how we work to set rates, whether we put it in as a line item in the budget, whether we take some of it out of reserves, or whether we borrow money for it. And so you can see that, you know, those are just estimates and, initial target of what we were doing for each of those. Some of them we were borrowing money, some of them we were, I think, does everybody have the CIP in their package?
I brought copies of it.
I just wanna make sure.
Yeah, it's in the
that-
package.
Okay.
I just wanna make sure. So, because that impacts rates too, obviously.
So is this already telling you that some of this has been already assigned to be bonded versus?
I think the
coming out
only
of
ones that are
capital reserve?
assigned that way are anything that's not projected. All the projected stuff is just target. So the FY 18 or 19 stuff has probably already been budgeted that way. But anything forward is just a target. It's just an idea.
Yeah.
The rate work will tell us whether we like that idea or whether we want to tweak something. But generally, we take the larger ones and borrow money. We take the medium ones, we look at reserves a little bit. We take the small ones and we kind of look at budgets if we can, line items in the budget. I mean, it's a little bit of, not a lot of science to it, but we try to, try to look at all your tools to fund it. And we also need to make sure we pay attention to the other things in the CIP, our reserves, what we want to maintain in reserves, and how we want to project and use reserves. I mean, I have some clients, we do a lot of rate work, where they want to drop the reserves a little bit. I heard some talk about, can we use some of the reserve money, or should we? And if we do, what happens? Or do we want to continue to grow our reserves, because we have asset management needs and asset renewal needs and other things. So we have to balance all that.
What is the amount of those reserves right now? Is it 3 million?
I think you're,
The reserves,
yeah, between your three accounts was,
I think it's around 5 million.
so it's over 5.
yeah,
Yeah.
5.7.
5.7.
But is some of that money already allocated for some of these projects? Where it's in here as capital reserves, basically?
No, this is next year's.
I think only in a general way, Don. I mean, nothing's,
Yeah.
I mean, it's,
To tap into those reserves, we need a vote, just of the commissioners, or
Just by the board,
Yep.
yeah.
when do we need the annual vote of the ratepayers? For some reason, we had that question last time we left here, right? We
Yeah,
weren't
it's still
quite
kind
sure
of
on that.
foggy.
If you're bonding,
Excuse me?
if we're gonna bond anything.
Okay,
Our
okay,
loans, right.
okay,
The-
but if it's available as part of the reserve,
Yeah.
this board can decide using it?
Yes.
Okay,
that's my understanding too.
okay.
Legislative body approves the budget and the bonds. So the other item I had on the agenda was just CIP, and I don't know if we've talked a little bit about it right here, but what we normally do is in the fall, December timeframe, we start pulling it out again, looking at the studies, the evaluations, and the reports, and we start creating drafts, and I think you'll start seeing versions of it, usually over the winter, and then it's just something we try to finalize prior to annual meeting. That's typically what we do, and then we usually update it once a year.
Is it common to move some of these around from year to year? Do you want to reprioritize one thing over another? I mean, listening to Jamie's discussion on, artificial recharge, and if there's a potential to maybe not have to use well 3 someday, I'd hate to have to, be budgeting for a $4.5 million pump station there that we may not need if there's other ways to get the same yield out of the aquifers.
Right, no, it's definitely a fluid document.
Right.
And it's something that we all sit together and say, hey, we got new information. You mean, artificial recharge isn't even on the
No, I
CIP.
know that, yeah.
Yeah, so it's something that came up since.
Right.
And since it seems to have potential, has legs, we ought to get it in the CIP, start having some capital numbers, and because it has the potential to either avoid the cost of a new well elsewhere or avoid the cost of a treatment plant elsewhere, we may want to delay those. And that's done, we do that.
Yeah.
We regularly do it.
We, like you said, we meet, we talk, and look at reports, and things shift around.
Yeah. I mean, obviously, we're gonna know more. He said he was gonna have a report in October, and hopefully that would tell us a little bit more information.
Yeah.
I'd still like to, I know as part of that artificial recharge grant application, there was, like 200,000 match. And I think part of that, he had a cost estimate of the infrastructure. I'd kinda like to get that up front before we consider authorizing that next phase of the artificial recharge. If we can break that out maybe, and I don't know if that would be you guys that would be putting numbers towards the infrastructure part of it.
It's usually us, I mean,
Yeah.
we haven't, we're not, that's not on our plate yet.
Yeah, I know,
but-
I know.
But, I mean, but, I was kidding with Keith when I looked at your list of questions for Emery and Garrett, and one of them was the cost of infrastructure. I said, yeah, Jamie's gonna be calling me. And in about an hour, I was like, bing.
Phone rang.
Hey, can you give me some cost?
Oh, yeah.
And in fairness though, when somebody asks us the groundwater,
Yeah,
question,
sure.
we call James.
Yeah,
so.
exactly.
Yeah.
It is a two-way street.
Well, it's a team, I figured you
That's
guys could
right.
figure it out one way or the other.
But that is something that usually, and we did that like on Mitchell Woods, it's exactly how it's happened. They came up with the site, they came up with the yield, and then we helped with the cost, the infrastructure cost. So we wrote a report that said, if you do connect it, this is the cost to connect it. The length of the pipe, the pumps, the mechanical, the electrical.
And I know you're coming close to, in a couple of weeks, hopefully you'll have a little bit better numbers on well 7 and 8.
Yep.
You know, I'd be looking at maybe considering implementing that, maybe, and, you know, my own opinion, maybe, I don't know if we need to push out something else here, the new well site at Mitchell Woods for another year and stick well 7 and 8 in front of that. I know we were thinking of polling the ratepayers about how they felt about that.
Mhm.
So, you know, I'm kinda looking to see what that number would be for that additional treatment at well 7 and 8. And I'm kinda looking at this as probably piecing it out right now. I don't know if we wanna talk about treating well 2 right now and well 3. Maybe just look at well 7 and 8 and the cost for the PFAS treatment. And maybe just looking at wells 2 and 3 PFAS treatment at some later date.
You'll have to back off a little bit on 2 and 3 and just concentrate on 7 and 8?
I think it would be good to know, and I think that was in your scope, so
Yeah,
that would
it
be
is.
good to know that.
We're doing it.
Yeah,
I mean, we're
yeah.
doing it anyways, yeah.
But I'm sure it's gonna be more money because it includes a whole full-blown treatment plant, which I know a lot of it is in this 4.5 million, the treatment plant, wherever it is.
Mhm.
Again, I don't think I'd be looking at doing one at well 3 and one at well 2.
Right.
Try to combine those together, which I think you're
That's what we're looking
evaluating
at,
all
you
of
know,
that.
so we can see what it costs at each, you know, as
Right.
opposed to the pipe to get it all to one place.
But I think we get more bang for the buck at well 7 and 8, because you already have the building there,
Mhm.
you know, and, depending on the priority that others would agree or disagree with, my opinion would be I'd like to see that, if we were considering putting that on the CIP closer than perhaps the Mitchell Woods well. And I don't know if the numbers would shake out to be about the same or not, you know, with the 1.5 right now here on Mitchell Woods. But maybe push that off a year or so later. That's just my thoughts. I'm just kind of sharing that with the commission here. And I know we might want to get some feedback from the public on what their, and in order to get that feedback, we kind of need what the number would be as far as a rate increase for the treatment at 7 and 8, if we were going to consider that.
Mhm.
And I think a lot of these pieces that you're talking about are gonna come together by the
Yeah, I
November
think-
timeframe, and
yeah.
I think we'll have this meeting and shuffle the CIP
Sounds
around.
like it, right?
Yeah,
How, can you model this like almost here, like in the session or something? Could you, you know?
It's a
yeah,
spreadsheet.
it's a
Like in a couple-
spreadsheet tool, and
right.
it's, as long as there's not a lot of sophisticated changes, like,
Right.
let's add a debt or take out a debt, I can do it pretty easily. There's other tools though, I mean, it's also easy to take your $3.5 million budget, add 350,000 to it, it's a 10% adjustment, I mean, so, it's an easy, that's a ballpark.
Would you share that spreadsheet? I mean,
Oh,
there's
yeah.
no reason you wouldn't, right?
No reason, no.
So we can kind of
I-
maybe run scenarios on our own and see.
You're welcome to it, I mean, it is a spreadsheet, it's not the simplest of spreadsheets. but
Yeah.
it is a spreadsheet, everybody knows how to use it. Our idea is that we generate it in a spreadsheet format so communities can use it if they choose to.
Sure.
I'm working in Belmont right now, they're doing some of the tables, and then we're gonna do some of the harder tables, so it actually helped. But yeah, no, it's yours.
Well, one thing, for example, is well 3, iron manganese treatment might not be making too much sense to put that on the radar right now if we're talking about artificial recharge.
That's what I was saying, yeah, it's,
Almost need to have a decision on that first before we even put that on the budget.
I think we need to
Right,
chase
probably
that
on the
down a
plan.
little further.
Because, I mean, that's one of the reasons that we're bringing up as a motivation to do it in the first place, so at least there should be a switch to maybe turn it off in the protection, right? To
And it's
see-
Mitchell
to
Woods?
see the impact.
What's the iron and manganese on Mitchell Woods, which Jamie
I
was
want to say
here
there's
with?
very, very good water over there.
Yeah, you had said that before.
I believe, I'd have to go back and look, but
Cause I know artificial recharge, we're only gaining essentially half of what well 3 is putting out, you know, so we kinda have to make up a little bit. If we wanted to do artificial recharge and take well 3 offline, we'd be losing some source capacity there, so Mitchell Woods coming in would be a help.
it definitely would be. I don't
Especially
think
if we
it's
don't
something
need-
I would want to put off Mitchell Woods. I think that's something we need sooner than later, for a couple different reasons. It isn't a high service, so that's could possibly be a backup
To
to
the booster pump.
the booster pump.
Yeah, cause even our connection to Pennachuck still needs to be boosted to the high service.
Correct.
Yeah,
Yeah.
yeah.
I just wanted to add one footnote. I did have a conversation with Brandon Kiernan about 7 and 8 Amherst investigation in the PFAS. Or
PFAS.
PFAS, yes. I keep wanting to say PFCs, and I
Just say PFAS.
PFAS, yes. And we're looking possibly to get them to come in and give us an update. Won't be this next board meeting, but possibly October.
Was that Brendan himself or no?
No, it'd be Mike Wimsat and Kate Emma? Yes.
From DES you're talking about?
Yes, yes.
Oh.
Come in and give us an update. And I kinda did throw out, and I didn't think it was, and he didn't seem to think it was a ridiculous comment, but seems like the contamination, PFOA is coming from all different directions over there, so it may be hard to pinpoint just one
Yeah.
person.
One responsible party.
Yeah, but I did throw out that, you know, they gotta be doing some sort of remediation out there, the ones that are currently on the hook. Is it out of the question to say some money for a treatment plant?
Yeah.
Would that, and it didn't seem out of the realm, so I'm not saying that it's a given, but I kinda planted that seed there as well.
Money from the responsible parties or from DES?
From the one responsible party right
Yeah.
now, there will be some groundwater remediation that's gonna have to take place. A pump and treat kind of system, and instead of doing that, could it possibly put towards treatment 7 and 8?
I see, yeah.
Would it accomplish the same thing? So those are kind of the direction I'm kind of
Yeah, if
headed
there's
over
any
there.
other sensitive receptors there or not, and if we're the biggest sensitive receptor out there, then treat the water that.
We're gonna be pumping it and treating it, we're not gonna be putting it back in the
Back in the
ground.
ground, yeah.
But does it kind of do the same thing with removing it?
Right.
Well, TCI is a responsible party along with one other company that has not been identified yet.
Okay. All right.
So that's something's coming up as well.
Are we done?
That's all we had.
We're done.
One last question I had was on well 7 and 8, you had the future tanks
Mhm.
in the building.
Yep.
We would still need to bring those in the building, right? Because there'd be no way to get them in the building, even if we weren't gonna use them.
Yeah,
Leave them empty?
That's a very good point. Yeah, which I really hadn't thought about. Yeah, and really, when I saw those drawn in, I was thinking like, yeah, I was envisioning resin there, you know, but, and that would be a smaller diameter tank. But,
Because it would certainly
yeah.
keep the cost down if we didn't need those second tanks, because we're not, with the limit at 70 right now, even if we broke through at 0% removal, it still would be below 70, so we don't need the lag tank there. right
Right.
now with the limits at 70.
Yeah,
So if we could defer that cost, if we chose to ever do anything at 7 and 8, it would reduce the upfront cost. Just don't know how you get the tank in the building after the building is built.
yeah, that's a big knockout. Or
Big
something
garage
that-
door?
that-
Yeah, I know.
Removable roof, you know?
Yeah, really.
I
Well,
was
that-
gonna say just open it.
Sliding roof.
Well, that's what they did over at Pease, is they
But you
took
almost-
they took the roof right off.
Right.
No, or a sliding metal roof, you almost wanna think about doing that anyway, because you don't know what's coming in 10 years.
Yeah,
Right.
And you can rebed these filters inside the building when,
Mhm.
I mean, you don't have to like take the roof off.
Right.
rebed.
No, no,
Yeah,
no.
okay. I didn't think so, but.
Right.
Gotta ask.
Man ways.
Yeah. So that's a little conundrum then.
Okay.
Yeah.
It's a good point.
Okay?
Yeah,
All right.
Thank you very much.
thanks, very
All set? All right.
informative.
We'll keep chugging.
Yep. Plugging and chugging.
Is it chugging or charging?
Chugging.
Well, when we chug, we charge.
Yeah, that proposal to look over, is that just for us to read?
Just for, Ron, yes.
We are done.
Helps.
We're all set, right?
Ron, did you have something that you wanted to say? This gentleman, does he want to speak?
Did you come in to speak, or?
Both.
Oh, then,
Okay. You can hang around, Mike. Thank you, gentlemen. Jeff Daly from Niles International MKD, also from Nashua. We talked to you, and Lou apologizes he couldn't make it today. He's down in Boston with the governor of New Hampshire. Couple of things. On well 3, we did talk about the iron manganese. That's one thing, the material we talked about, it eliminates that, and would eliminate automatically, would have no chlorine necessary to go forward if you went with a synthetic resin, as opposed to the resins, well, the material we're talking about. So that would cut your costs. And we did talk to Mike about a joint venture with Niles and Underwood, and I talked the same thing with Jamie, and he said it makes sense, especially if we can come up with a better system that works and is approved. Right now, the tests that we're carrying out down at XTD Labs are proceeding. The main holdup is getting the analytes out of the laboratories, urofins and what have you. They're so backlogged. Right now, they're talking 4 to 5 weeks, and now that's suddenly gone to nearly 6 weeks. We've got 3 major tests that have just been done down at XT Labs in Stratham. We're just waiting for those results, but at the moment they look very, very good. A number of them came back non-detect, but now we want the full certification of those tests. The removal of the heavy metals, non-detect. Phosphorus, non-detect. I don't know if you've got arsenic around here, a lot, but the sodium and the chlorides absolutely can be taken out. And then all it is now adjusting for the correct blend quality and the amount necessary to give you, should we say, a year's life out of the bed. And that's what Lou and Scott and everybody are working on right now. So that could be very, very interesting in that everybody could cut some costs and your CIP would drop accordingly. We're not talking millions in cut, but a couple of 100,000 here, a couple of 100,000 there. And then as far as the tanks are concerned, yeah, those could be put in and left empty. And you can put a peelable spray coating on them so they don't rust out or anything like that. And that's standard in the industry. Then the other one is, where was it? Yeah, the sodium levels you said were pretty high, and the chloride levels, that we can take care of as well without using the sodium or potassium chlorate to flocculate it out. That's, again, another savings, and we did talk to Mike about that as well. And it's something that, you know, if we all get together, can be considered going forward.
So you're saying that the zeolite can remove sodium and chloride as well?
Yep.
Really?
Mm-hmm. It has
Iron
an
and manganese, I mean, this
electrovator.
sounds like the greatest stuff.
Well, we're doing right now, the tests are being done down at Savannah River on the sodium salts that they have, which get left over from the purification of uranium and plutonium. And they got it down to 0. And that was without chemicals. Right now, it's a chemical flocculation that they use. And there's about 3 or 4 different chemicals they have to use, because some of the salts are radioactive, some of them are non-radioactive, because they mix and blend them as it goes through the process plant. They all get dumped into the same tank. We've got 65 million gallons of it down there in Savannah River. They got 500 million gallons out in Hanford.
Are all of these studies relatively new, or?
Yes.
Because I've been asking around, DES is, you know, basically the answer is that there's not a lot of data out there. And,
This stuff has been used by the federal government in Sandia Labs for 45 years. And prior to that, it was used on the Manhattan Project in HPLC columns. That's basically where they first started off. In Europe, they've been using it for a long time, but not the same type of blend and finished product that Lou has put together.
I did read up on that, actually. I've seen it in a couple of communities in Europe for
Right.
some time, but we do need more, you know, substantiated
Yep.
data, unfortunately, to
Well,
really
to be honest with you,
see that.
the reason Lou has been flying under the radar is we are going to disturb the whole of the GAC business model. Because the average pore size of GAC is between 800 and 1500 angstroms. The average pore size of what we have is between 4 and 20 angstroms. So we're that much finer. And with the new stuff that, because I have a grinding mill which I used to handle, we put it down at XT Labs. We've now got it down to 425 mesh, and it's about 3 times more effective than 325 mesh. And we're having an electron microscope photograph taken of it to see why. It's just pure surface area. And they're going to be running some of the 250-pound pressure tests to make sure that nothing comes out, because that's the primary thing that allows this material, if people want, to landfill it. But we've got secondary use. That's why Lou said we will, working with Underwood and what have you, we'll take care of all that. You don't have to worry about it. If we say, all right, 6 months from now, 8 months, whatever it is, we come in and change out the complete load, you don't have any liability, nothing. And then we use it for the secondary use. Right now we've got 62 million tons of it available in fly ash alone. So that is what we're working on. And if you want concrete, Ron, we can supply you with the best concrete in the world. You cut back 75% on Portland cement. Think of the emissions of making Portland cement is reduced by. Increase in strength of the concrete, much lighter, and a higher corrosion resistance. Right now they're running some tests in a salt chamber, and they see nothing. But if you see all the sloughing on your concrete on the roads, bridges and stuff like that, they've got some stuff running now for over a year. Perfect.
It'd be good to get some literature out on some of those tests that have been done, different sites and things.
Yeah, I think Lou sent you some results on the Rochester phosphorus removal. Ron, remember that?
I'd have to go back and look.
Okay.
He may have.
Yep.
Yeah, I mean, we're looking at things that would affect our water would obviously PFAS,
Oh, yeah.
iron, manganese, that's
Well, the
what it's
first,
all about here.
first series of full PFAS was started on Hoosick Falls. We got 1,700 parts per trillion. We went straight down to 79 parts per trillion in a single column. Then they ran it again at a slower rate, and it got down to just above non-detect. So we know it works, but now it's a question of running a full scale, and that's easy to do. You know, it's just a question of, well, we've already taken water from over where, not far from well 7 and 8, which has got 395 parts per trillion, and one of them came back, you know, that's got to be certified, is non-detect.
So last time you were here, I think you talked about getting some water samples from wells 4 and 5 and running a
Yes.
test on that or
Yep.
something.
Yeah,
Mike
and I gotta coordinate with,
Right.
you know, the day and all of that, so yeah, that's still in the
It's
process.
still in the offing, yeah. Now that you know, you can open those up,
Yeah.
Yeah, has that
which
been-
was a stumbling point.
You're gonna let you pump back into the ground or onto the ground?
For a limited time.
Yes.
Yeah. Okay.
Yeah, but basically under the protocol that they have for construction dewatering in the groundwater management zone around Saint Gobain, we, you know, based on what they have said, they said, all right, yeah, you can run your short-term test in order to get water quality samples. So I said, we can put it on the ground, and I said, I want to run it for about half an hour, and I didn't have anybody tell me I couldn't, so.
Yeah, quick.
Yeah, so I figure I'm okay.
It's coming out of the ground, you think you could put it back on the ground? Not so simple, I guess.
Yeah, sometimes that's not so simple.
It depends how compacted the ground is where you're running it.
Yeah, I suppose.
It'll pond and then just, you know, go in. But no, once we can do that, talking of where wells 7 and 8 are, in the Amherst Hollis area, they've got some wells that are registering in the thousands of parts per trillion. There's one well not far from 7 and 8, maybe less than 1,000 feet, and that's measuring 9,000 parts per trillion. And
Really?
it's all sloping down towards Witch's Brook, which is right where 7 and 8 is mounted.
I wonder if the DES, we just talked about that, if they come here and do a presentation, if they can show us what's going on with all that, you know?
Thought you said he was coming next week, next meeting, next month.
It's in the works. It won't be the next meeting, but possibly
Hopefully October.
October. That's what I was shooting for. I thought this next meeting was too close, too short of a time.
I know.
If that's on the move, that's kinda concerning, you know?
Yeah.
That stuff's
Yep.
moving.
Well, 2 of the wells there, they've had to retest and the numbers have gone up.
Kinda
We're
seems
supposed to be in a drought. You know, how's it getting there? It's getting there because it's all flowing downhill.
What numbers to come, the concentration or the?
The total, PFOA, PFOS. You see, they have not been measuring the full annulite that they now want. So it's just those 2. And there's one there, it went up like 400. So it was about 85, now it's just, you know, just under 9,000. And these are all within the area from 101 back to Witch's Brook through that whole industrial park there. But DES had a new set of analysis coming through, and I think they're caught like us. You know, the labs are just so loaded. You know, forget the hospital doing the blood. That's the thing.
Yeah.
It's mind-boggling, and I hate to say it, they've known about it since 1966.
Mhm.
Remember that letter we gave you? DuPont wanted to coat a particular material that's used in the food industry. FDA said no. back in 1966. Never passed the information on to EPA. Yep. So here we are today, you know, people like Mike and everybody, we're trying to help you out and resolve the problem. You know, and it goes from there, all right?
Well, I think if you get a level of comfort for the regulators, the engineering community,
Mhm.
and us, you know, of the efficiency of the zeolite, they make us feel better.
Right. Well, that's the thing that, you know, Lou, you know, we know the surface area, we know the capability of it. It's just now making sure that, one, the full water analysis is fully understood, with the percentage of each material that is to be removed, because the zeolite will remove far more than just PFAS. I mean, to go non-detect on the wastewater side of the Rochester plant, they couldn't believe it. And that was a full-blown test. And then the same thing we did down at Savannah River plant with the salt.
My concern would be the longevity of this.
That's why Lou, once he knows exactly what percentages are, and we know what we're putting through the columns in the lab, it's no good saying, oh, well, we've got 5% PFAS and everything else, and all of a sudden we've got 45% calcium. That could...
That, and it's fine to do that with 2 gallons or 20 or
Right.
200 gallons, but not what with, you know, 600 gallons.
Well,
of it, so.
it can be extrapolated, and we're doing that with another company down on the seacoast. And the Air Force at Pease are looking at the same thing, because they've had to put, and Mike could confirm this, they've actually put synthetic zeolites in, and it got an incredible result from it.
I can't verify that. I don't know what you're talking about. just to be clear.
Well, it is an experimental facility, admittedly, but much better result in GAC.
And that's exactly kind of what I'm saying is if from multiple sources here, if we can, you know,
Right.
confirm these awesome claims, then I think everyone would feel a lot more comfortable about
And the industrial
considering it.
application.
Right,
That's
well,
my
that's why-
concern.
why
It's
Lou-
one thing to do that in a lab, but to do it consecutively, day in, day out. I'm not questioning it.
No.
I'm just saying, you know, to spend money, to sit here and decide on spending money on it, we need to see
Well, we're
some
running
proof
through
of
right
industrial
now
application for it.
4-inch columns, about that long. And so when we go to the big filter, you know, like the frac tank system, you're talking like 10 million times the surface area. I mean, we're doing it out in California in the Salton Sea, and removing sodium there down to 150 parts per trillion. You know,
If you have some documentation on that, I think a lot of people would be interested
Right.
in
Absolutely.
part of
seeing
that, though, I will tell you, the Salton Sea, that is the federal government, they don't want that out, because the numbers we're going from down to, I mean, you say, what the hell have you been doing? Selenium is part of what we're taking out.
I mean, I would think like AWWA or something would love to get their hands on kind of these
Problem is they're
stories.
sponsored.
Yeah.
That's the problem, Don. They are sponsored. And there are a number of people out there who don't want even some of the guys who make synthetics to get in on this. You know, the Dow Chemicals. It's part of their huge business model. And you, as people who are trying to give clean water to the community, you're caught, you know? Just like Brendan said, yeah, we know what you're doing, but we're also tied up by the law. And we've got to start changing things. You know, you have enough red tape as it is. You can actually ingest this material. It will take any of the nasty stuff out of your stomach and your intestines and what have you, and absorb all that stuff. And they've done some tests in one of the universities for kids who've had lead poisoning, and it's in their gut, and it took it out. Can't get into the blood at the moment because that's early days.
Yeah.
So, but Flint, Michigan is our next visit.
Huh.
Because we can remove all the lead from there as well. So, all right, so you're gonna discuss the original, stuff that we talked about in your own session. Appreciate it, gentlemen.
Thank you.
Thank you very much.
Thank you. Accept the motion to adjourn.
Thank you.
Motion to adjourn.
Second.
I'll second it.
All those in favor?
All right.
Aye.